We are at 0, so we have to start. This is quite some interesting and new way for us to do stuff, but I think this is the future where you're going to have to stream, have a limited number of people maybe in your classroom or in your venue. I'm very privileged that we are today here. We will at the end, I think about 30. So it's very exciting for us to be here, and I'm glad that you all can be there. Tanya, this was a dream of us to have it in person, and I'm very privileged to say that we are here in person today. Even though we have sanitizer on the tables, we're going to keep the windows open, so if you're called, and that's just for the flow and so on. And then also a word of welcome to our people that is on Zoom. So I'm going to now also welcome Prof. Jan Elof, the Dean of the Faculty of EBIT, and ask him to say a few words. Prof. Jan, when you are presenting, you have to please stand here to the mic so that they can catch us on the streaming. Thank you. Thank you, Prof. Jan.
Right, thank you. Good morning, ladies and gentlemen. Thank you very much, Professor van der Merwe. Very welcome here at the annual EBIT Teaching and Learning Seminar Workshop. Also, allow me a special word of welcome to our Vice Principal Academic, Professor Norman Duncan, for making time available to also come to our event today. I think it's very well known in the University of Pretoria wider circles, if I can put it that way, that under the leadership of Professor Duncan for the past number of years, that teaching and learning indeed was put on the next level. And I think that's very exciting to say. Also, I would like to say a special word of welcome to Professor Karen Wolf. She's from the University of Stellenbosch. I'm sure most of you haven't heard about the University of Stellenbosch, but I'm sure she will explain. Very welcome here, Karen, and we're looking forward to your keynote as well. Just lastly, I would like to congratulate Professor van der Merwe and also say thank you from the EBIT executive for arranging this workshop. Doesn't go easy. As I know the amount of work she puts into it, but this really is a catalyst to actually help us in EBIT to go to the next level with regard to teaching and learning. Thank you, Alta. I'm asking Professor Duncan to say a few words now. Thank you.
I'm a tad shorter than Professor Elof, only a little bit. Thank you, Professor Elof. Good morning, colleagues. Special word of welcome, of course, to Professor Wolf. Firstly, let me say that I feel privileged to be invited, for having been invited to say a few words at this event. I want to thank the faculty for remembering me every year when they have the workshop. I think it's the third or fourth workshop that I am participating in or helping to get off the ground or to launch in the first session of the workshop. Thank you so much. Now I need to ask the technicians to quickly help me load my presentation. Thank you so much. Colleagues, I've been asked to just say a few words about where the university is going to into the future in terms of teaching and learning. Now, I thought when Professor van der Merwe had asked me earlier in the year to speak to the participants in the workshop about the coming year, what our plans are for the next year, that I thought that I was going to speak about the fact that after 20 months in lockdown or various levels of lockdown, after 20 months of dealing with the fallout of the pandemic, that we'd be able to speak about the possibility of coming back next year. In fact, until about 3 weeks ago, I mean, that was firmly on the cards, that we would try as far as possible to restart the process of teaching in contact mode, because we know that contact mode enables us as a university to offer our teaching, offer instruction, allow for learning to take place in hybrid mode, which is the ideal mode for our context, for our students. I mean, it has the advantages both of online as well as contact. Unfortunately, I mean, over the last few days, we've heard that there seems to be a spike in infections in South Africa. It appears that the province of Gauteng is more severely affected than any other province. In fact, 61% of all infections at this point in time are in the Gauteng province. So that, of course, puts a span in the works. I mean, so clearly we cannot, while we're still aspiring to or have aspirations in terms of having some modicum of contact teaching next year, the possibilities look fairly slim at this point in time. So, I mean, as had been the case over the past 20 months, we will prepare ourselves for any eventuality, the possibility of hybrid or the possibility of primarily online. But I suppose the point that I want to make, and this is in terms of where the university is heading in terms of its teaching and learning aspirations, the point that I would want to make is that while we had hoped 20 months ago, that this would be a bit of a blip on the radar, this pandemic, and that soon we'll get back to doing the things the way that we've always been doing things, that no longer seems a reality. So while over the past 20 months we were in holding mode, we were trying to manage, we were trying to survive the pandemic, if it is as I predict it will be, that the pandemic will be with us for many, many more months, we cannot now remain in holding mode with expectation that we will go back to a situation that had prevailed prior to last year. That we now have to, and this has always been the case at the University of Pretoria, that we focus on teaching and learning, we focus on innovating in terms of teaching and learning, to be ahead of the curve, to innovate I suppose, in the interests of our students, to really drive student success. If the pandemic is going to be reality for many more months and the impact of the pandemic, then I think our responsibility is to now see how we can innovate even within the context of crisis, that it is no longer trying to replicate and trying to function in a way that we had functioned prior to 2020. This is the reality for the foreseeable future, and how do we innovate in this context? Colleagues, I thought it might be useful, and Prof. Alta told me I've only got 10 minutes, so I'm going to not dwell too long on any of the points I'm going to make. But I thought it would be interesting or useful for you, I hope, Prof. Alta, that it will be useful, just to highlight a few of the things that I think are important for, in terms of our teaching and learning portfolio at the University of Pretoria. What are the things that we will be prioritizing as from next year? Now, before I forget, and I suppose this is something that I should have said at the outset, is that I need to acknowledge the work, obviously, of the leadership of the Faculty of Engineering, Built Environment and IT over the past 20 months during the crisis. Obviously, even prior to that, I mean, the Faculty of EBIT is one of the stronger faculties in terms of innovating in terms of teaching and learning. And I've obviously got great admiration for the work that is being done in the faculty. I know that much of the innovation, much of the hard work, and you are working under really extraordinary circumstances, is due to the innovation and I suppose the commitment of people on the Teaching and Learning Committee. And I know that members of the Teaching and Learning Committee are here today. So I want to make use of this opportunity to thank you for holding the fort, for ensuring that we can continue, that we can complete an academic year as we had done last year, and as I'm confident we'll be doing this year. These things don't happen automatically or organically. They happen because people are committed, our staff and our colleagues are committed to, I suppose, the progress of our students and the success of our students. And I want to come back to that point, the notion of the success of students under whatever circumstances we are confronted with. That for me is of critical importance. We are here because, firstly, we are passionate about research. We are passionate about, I suppose, the performance of our universities nationally. But we're also here because we have an important responsibility to ensure that we groom a next generation of academics, next generation of professionals. And so for that reason, it is important for universities to always, yes, I know all our research-driven universities have to prioritize research, and that's good. That's what universities are for. But it's equally important for us to prioritize teaching and learning and the success of our students. University education is very expensive, and we have to ensure that we put measures in place to ensure that as many students as possible are successful. Now, very quickly then, through the stuff that I would want to highlight that are going to be seen as priorities in the coming year. In fact, it's part of our strategy for 2022 to 2026. The one important thing that we have to look at now, as I've indicated, we cannot see how we're functioning now as exceptional. It might become part and an important part of our reality into the future. And for that reason, we have to now start looking at what are going to be our predominant modes of instruction at the University of Pretoria. Yes, at the beginning of the pandemic, many people wanted us to just get through this crisis so that we can go back to contact mode in the old fashion. Not even in the hybrid fashion. That is no longer the case. We'll have to experiment with new ways of doing. Increasingly internationally, I mean, people are focusing on ensuring that instruction becomes as flexible as possible. I've seen the blip on or the blurb on the program for today. Let me just have a look at it again, because I think it illustrates what I want to say, and that is that we have to have a model that allows for teaching anytime, anywhere. In other words, that we have a system that's as flexible as possible. However, we cannot just jump into new modes of teaching and learning and adopt new approaches to teaching and learning without testing the viability and the potential success of those approaches. And for that reason, all the deputy deans teaching and learning at the university have been hard at work over the past year to look at what should be our preferred mode or modes of teaching and learning at the University of Pretoria. We will have a design thinking session around focusing on the predominant modes of teaching and learning at the university early next year. There will be sufficient space obviously for all the deputy deans teaching and learning, because they are the drivers of this initiative. But I hope that there will be sufficient space for some members of the Teaching and Learning Committee of EBIT to participate. Now, very quickly then, obviously, if our reality is going to remain more or less in this mode around teaching and learning, that there will be an increasing reliance on technology in order to offer optimal and excellent instruction, then of course we've got to build and expand our infrastructure. And that pretty much forms the core, the backbone of the 2022 to 2026 teaching and learning strategy for the university. We have to expand the resources that are available and strengthen our usage of those resources in order to enrich the learning experience of students and in order to ensure greater levels of success. I need to highlight once again, colleagues, that this is one of the things that preoccupies me all the time. The fact that we enroll students with exceptional ability at the University of Pretoria, but then despite that, our levels of success are way too low for a university with the types of resources that we have and the quality of students that we enroll. So everything that we do at the university is ensure that we give our students an enriched experience, but also to ensure that they success according to the standards of the faculty and the demands of whatever professions that they are going to go into. Now, there's a last item on this agenda, which is my new pet project. Prof. Alta knows about this, and that is around expanding the horizons of our students beyond the realities of UP and beyond the realities of South Africa. I think the fact that we have become quite adept at functioning online tells us that, or at least gives us motivated me to say, why don't we utilize our agility, our ability to navigate online to expand the horizons of our students? Now, I suppose in more affluent societies, in more affluent countries, like countries in Europe, one of the things that have given their graduates an edge over other graduates is the fact that they had a study abroad program. They could afford a study abroad program. Obviously, with the pandemic, that was no longer possible, and they had to start experimenting on making a study abroad program possible online. And so within this context, and given the resources that we have, it is very possible for us to give our students an experience of engaging with students at other universities, at partner universities, or at exceptional universities, and I suppose the learning and the value will be reciprocal. The partner university students will benefit from the expertise of our lecturers, and our students will benefit from the expertise of the partner universities. I'm asking all faculties, and I know that your faculties already started on this process of having a global learning experience made available to our postgraduate students in particular. I'm asking all our faculties, in fact, explore that, and it need not be a major thing. And of course, it has to be carefully crafted and carefully calibrated, because we want to add quality to what our students get. We do not want to give them second-rate and shoddy service. So I'm asking all faculties, see what modules can lend themselves to an online class with students from UP and students at Wayne State, for argument's sake, or students at UCLA. It can be a small portion, and it can grow as the years progress. That's so important. Our students, once they leave the university, it's not like in my generation. When you left the university, you realize that you're going to work, obviously, and you're going to work in South Africa. But the world has become so small, and it's accessible to most of our students. So many of our graduates end up elsewhere in the world, and we have to give them the opportunity to be sufficiently skilled, in fact, to cope well. I'm going to move very quickly through the rest. We will, as I said, focus on student success, and there are various projects that lend themselves or are geared towards enhancing or improving our levels of student success. The Fly at UP project, which was started some 7-8 years ago, has to be recalibrated. It's quite important that we refresh the program, otherwise it's going to become a tired cliche. As from next year, the Fly at UP project, the recalibrated project, will focus primarily at students who our predictive analytics tell us will be battling at, might find problems at university. So we will gear and start focusing our efforts in relation to Fly at UP at students who might be vulnerable or at risk of not succeeding. Then, of course, an initiative that Prof. Alta is integrally involved in, the Chair B. Hims project, will continue. We will focus on those modules where we have lower than desirable success rates and see what we can do to improve the success rates. Then in terms of curriculum transformation, this is quite important. I know your faculty is doing important work and exciting work around this. It is time for us to, I think, look again at our curriculum transformation framework, just given our experiences of the past 20 months as well, and our expectations of how the world will change within the next decade or two. Before we start that process, however, of recalibrating our framework, I've asked all faculties to give us an update on how far they've progressed in terms of transforming the curriculum. Those reports are coming in at this point in time. We'll have a look at that and make recommendations to faculties. Then, in terms of social responsibility, I want to acknowledge the work of EBIT. I think EBIT is a big driver of community engagement projects. And Prof. Alta, I keep on forgetting the course code that your students enroll for. the JCP. Really an extraordinary program. If one watches the videos of the students' project, it is truly inspiring, and it makes one proud of being part of this the University of Pretoria community, because for the simple reason that it teaches our students that the skills that we acquire through the privilege of being at university are not our skills alone, and that we don't only use it for our own advancement, we utilize it for the benefit of our society. That is a valuable and it's an essential 21st century attribute. It's part of the, I think it's one of the key principles or one of the key elements of our Graduate Attributes program. And then, of course, the one important point that I'd want to highlight, and Prof. Stolz will emphasize it when he writes to faculties, is the fact that we have to start focusing on the scholarship of social responsibility and community engagement. We're doing exceptional work, but we're also a university, and we have to translate what we're doing into research so that we can further refine what we're doing and how we're engaging with communities. This is an important area of scholarship. Very frequently, community engagement and social responsibility is seen as an add-on. It's something in addition to what we do. In your faculty, it's part of the curriculum, but I'd want us to start doing research around that so that the benefits of our involvement can be shared with other universities and other communities. Graduate employability is important. I'm not going to dwell on this given time constraints, but here again, the university is taking its lead from the faculty of EBIT. I think many of the initiatives, the career mentorship initiative, started in this faculty, and it's now being rolled out to the entire university, and all in an effort to make our students more employable when they leave the university. Prof. Alta, I can carry on for a very long time, but I hope that the pointers that I've given will suffice for the purposes of this workshop. Thank you.
To say a few words and welcome Prof. Wolf here today to our lovely weather that we've arranged for her. We hope that she's going to enjoy it. We hope you're going to have fun. We want to say thank you that you have joined us here today to give us this presentation. And Prof. Wolf is from the university. I don't know if you've heard of it. A small university, as Prof. Jan has said, as Prof. Norman has said, they're in the southern part of Africa, still struggling a little bit, but no. Prof, welcome. She's from University of Stellenbosch, and she's going to show us a few things. And I came to learn to know Prof. Wolf when I was working with Helen on the WEAVE conference, and I've come to know her as a person with a lot of energy, and I hope that her presentation today will come over as and portray for us that energy. Thank you, Prof.
No, the tech issues. Oh, can I take this off now? They're seeing me online too. Hello, colleagues. There we go. I actually just want the pointer part of it. Colleagues, thank you so much. And Prof. Duncan, I'm so glad you haven't jumped up like other VPs and run off, because I'm going to be talking directly to you. So Alta has given, because it's the perfect program, Alta. Congratulations on the perfect program, because everything you've spoken about I'm going to address now, today, and I'm going to kind of show you practically how this actually has been playing out in my little down south university at the bottom of the country, Stellenbosch University. So you've had an introduction to me already, and I'm really, really privileged to be here. And also because I was here in 2016 And there's a connection. In 2016, I was part of the evaluation team looking at the the Engage program, because the whole access and success issue was a major thing for me. Now, I don't know how many of you remember this proposal for undergraduate curriculum reform, which came out almost a decade ago, almost. But we were working on it. And I was on the task team with Professor Ian Scott developing the engineering diploma at that stage. And the point about this whole report was that there is something fundamentally flawed in our system, we know, in terms of what we mean by access. And I'll talk to Wally Morrow's concept of, it's not just throwing the doors open, it is enabling all kinds of access. And I think we've gone way beyond epistemological, knowledge-based access. There's a bigger picture here. And even today, when we look at our numbers, we've got shocking statistics, and it's not just in our country. Globally, we have major issues in the STEM space in terms of recruitment, retention, access, enabling success through the system. So, one. In that report, and I think what so many people missed, was there were 4 fundamental curriculum principles. And the main point about the report was that we're throwing away a lot of money on a foundation model that goes 1+, okay, the so-called bridging year. That can work in some senses, but there is way more to bridging and foundation and scaffolding and building. So the intention of that report was, 1, to suggest we need to rethink our foundation funding model. And the success cases in a follow-up study that I did with Professor Sue Ellen Shea, who was in fact my PhD supervisor at UCT, we then looked at 4 case studies of the 4 different kinds of institutions and what the picture was in terms of which of those extended programs were actually working. And the ones that were working, Leilani, where are you, were the ones that were adopting an integrated scaffolded approach. And it was an integrated scaffolded approach to those 4 key curriculum principles. And when you regard them as a whole, what you get is, and here we go to scholarship of teaching and learning, the notion of cumulative learning, the building. And what I'm going to do today is I'm going to demonstrate those 4 principles and how one can cumulatively build them using the affordances of technology. And I'm going to problematize what is it and how is it that students actually learn at different stages across a program and within different subject areas with different kinds of technologies that might speak to exactly the things that are glaring or staring at us right now, that speak to issues of flexibility, speak to issues of so-called 4th Industrial Revolution readiness, because that's about the whole employability driver. We do not, in engineering, teach foundational, formative, general programs. They are professional qualifications. They are endorsed, accredited, there are all sorts of guidelines. So employability and socioeconomic legitimacy is a huge part of our mandate. That's what we're preparing our students for. And I'm going to demonstrate how to pull these 4 curriculum principles through in our particular Stellenbosch University context, where I've now been working for 7 years, slowly building an approach that has been really useful in the current times in which we're in. So let's just look at these principles quickly, and I actually need to read you the official definition. There is a, do you like my lovely bridging the workplace gap graphic there? There is a recognition, this comes straight from the report, or from that original proposal. At entry level, there's a recognition that serious knowledge gaps need to be filled given problematic curricular assumptions about students' prior knowledge. And here's my favorite one. This is what everybody misses. Epistemic transitions. There is a need to explicitly scaffold students' epistemic development beyond foundation provision across all those knowledge areas we're talking about there. And in South Africa, in our BEng programs, we very much teach along that line, starting with the natural mathematical sciences and then into the engineering sciences, etc. Okay? We're going to get to that and unpack that in a moment. There is the need for curriculum enrichment through all the key literacies. And literacies here are not teaching people to speak English or any other language and writing essays in those languages. Literacies here are academic, disciplinary, digital, quantitative. One of our biggest complaints from industry is our students don't know how to use Excel. They don't know how to do basic quantification of things when they're looking at production line processes. They can go and do differentiation over there and not pull it through to, let's say, a production line process. those kinds of literacy practices, enrichment. And the fourth principle is there's a need to enable greater breadth, precisely what Prof. Duncan was talking about, greater breadth of exposure in order to produce graduates for the contemporary world. Right. Here's our fundamental problem. And it's because of our assessment systems. We break these up. We see those four principles as totally separable. We outsource the foundation. Somebody else is going to teach them the maths and the science and the physics and the chemistry and the whatever. Oh, and suddenly by osmosis and magic, this is all going to come together now somehow when we're teaching strength of materials second or third year or whatever, okay, in a particular application context. We treat the academic literacies as a totally separate issue, and then we do these add-ons with, okay, go and do a job shadow or an in-service training or a little stint in the workplace. There's no cohesion. And what that original, and this comes straight from our presentation of that project, was all the programs that are more successful are those that embed all the principles. They embed the foundation and this enhancement within the disciplines through the kind of integrated approach that you have in your Engage program. Okay, the kind of integrated approach, more lateral relations between the whole interdisciplinary, cross-disciplinary working amongst each other. Okay, but how do we do that? What does that mean? We can all spout, oh, we need our graduates to be more flexible. What does it look like in practice? How do we get there? That's what we're doing today. So, and I'm going to take you to the Scholarship of Teaching and Learning for a moment as the first foundation tool to talk about this. This is actually from the Sociology of Education. Now, our job is to help our students to connect the dots between why, what, how, in the context of who, where, when, and 21st century, what if? How many of us are teaching for, but what if? What if is the biggest thing right now? And look at COVID era teaching. Look at all of this. This is the what if. And Prof. Duncan was referring to this about, we don't even know. We're sitting on the cusp of 2022 and we actually don't know what's going to happen. Right. Now, that connection between principles and procedures or theory and practice, if we do this properly and if it builds, we call it cumulative learning. Okay? And this instrument that I'm showing you is called the semantic wave. Okay, it's from Professor Carl Mayton, who was my other PhD supervisor. Fantastic gentleman. Now let's lay those four curriculum principles on this semantic wave. Okay? Please note, within each of those four principles, there is a wave in itself that does exactly what we're going to do on the y-axis. We're going to talk about the connection between abstract concepts, pull them down into concrete or contextualized examples. Now, you all do this in your teaching. You go, here's a concept, this is what it looks like. But if you go, here's a concept, this is what it looks like, and you leave it there, and then we go into, right, let's do the maths. Then you're doing what we call in semantic wave terms a downward escalator. And downward escalator is what we do in our higher education system all the time. It does not lead to cumulative. How do you pull that back up again? You can't just say, here's a concept, here's what it looks like. How do we pull that through in each of these kind of bands? Now, our biggest challenge, we know about the problems with foundation, and we're all trying to catch up and deal with them all the time. We ignore the literacy practices, depending on where you're at, and we leave the enhancement issues for somebody else to worry about, the projects, subjects, etc. Our biggest challenge, and what we've picked up now, COVID era, how many of you currently, your second year, second semester students, have really battled? Anybody? Right. I got the first emergency email going, oh, fluid mechanics, followed by thermodynamics, followed by strengths, followed by material science. Thank goodness I've been on these projects because I could tell you what the problem was. That epistemic transition space, in other words, the movement from pulling together the physics, the chemistry, and the bio stuff, if you got that included, coupled with the mathematics, into something new called an engineering science, thermodynamics, fluid mechanics, all of those things, is totally different from the science and the maths. It's a new step. So Let me just zoom into it. There we go. If we look at those steps, everything from the top left compounds and is added by the time we get to the bottom, okay? So our biggest failure and dropout rates happen here, and I know this from the national study when we looked at the different institutions. We get them in that foundation phase stuff through the maths and science, and there's quite comparable stuff between extended, for example, and other. But when we hit that engineering sciences block, things are starting to fall to pieces. The next big block is here. Now the problem is, by the time you get to design, you need everything else before it in its own way, cumulatively built to enable you to tackle a real world problem, or even an idealized problem for potential real world. And here's the issue. Our lecturers don't know, oh my word, what's the problem? You can look and see, okay, but there's a calculation related issue here. Or sometimes it's as basic as number concepts that fall to pieces. Sometimes it's just simply not the grasp of that original science, okay, of the original fundamental natural science concept. What we do know, if we now enter the phase we're in now, is that with all those initial reports, the biggest issue in South Africa and many other places, I'm doing a study with the University of Düsseldorf as well, and you'd be surprised at how similar this is, given they've got the bandwidth, they've got the equipment, they've got the tools and technologies and everything. Same kinds of issues. The assumption of digital fluency. So for those of you who are teaching, I'm preempting a little, who are teaching online, and let's say giving your students access to, I don't know, LT Spice or something to run simulations, and students coming back and one, not having bandwidth, two, not being able to, or in the MATLAB Simulink cases, in our case, installing the wrong software, getting all lost in that space. There's a reason for this. The thinking when you're using a technology, you know this, is totally different from calculating a mass and energy balance, or from getting stuck in all those tutorial problems applying the maths. Okay, so I'm going to dip into there for a moment quickly. So when we talk about this kind of thinking, and this comes from my own research work, those natural sciences work as a radical simplification, but the natural sciences work in what we call a very sort of linear hierarchical sense. You need to have every concept in the base built slowly but surely before you can add something. So if we've got force at the top of that, you want to add torque. Torque goes above force already, okay? In other words, it's all of those base concepts must be in place, and we tend to teach like this. Look at the school curriculum. You will see we teach in that sequence from primary school through to high school. Now, when it comes to the mathematical disciplines, there are multiple kinds of mathematical languages, multiple, okay? And they all work in the same way, a little bit like that hierarchy in the natural sciences. You've got to have little chains of what are the rules of the game that are into, and this is what linear algebra looks like, and this is what trigonometry looks like, this is what this looks like. We could take a number of different mathematical languages or types of mathematical branches to solve the same problem. We know this. We haven't got space in our curriculum to say, okay guys, hang on a moment. When we're looking at this flow rate problem here, yes, this is what we're going to do on the physics side in terms of analyzing it, but actually, you could represent this graphically, you could do a straightforward algebraic type relational equation over here. There are different mathematics we could apply to this, but both of those are almost what I want to describe as fairly linear. Here's the problem with technology. Technology isn't deductive, and going back, what are the first principles here in terms of how I'm using this? Technology is just all the tools we use are different kinds of languages which change overnight. They change overnight. You try and install one version backwards of MATLAB, and you will see for yourself. Even the navigation changes. Every single one of our cell phone iterations drives us all insane, because the fundamental overarching principles are not the same as they are in fluid mechanics or thermodynamics, the laws of thermodynamics, or Ohm's law. It's a totally different kind of thinking we're talking about. And that's what we saw now during this whole era. Some people were not prepared for this kind of thinking, and we know that that bottom graphic, which is a radical simplification, is what we're trying to accomplish when we get to design in the for the real world and solving real world problems. So how do we get there? How do we get our students from this linear? Please don't misunderstand me. We need that anchoring. We need those procedures. We need them to be equipped there. But we need to teach them how to pull these together and then stretch it cumulatively. So what I'm going to show you is this fantastic group of colleagues that I have in process and chemical engineering at Stellenbosch University, whom I absolutely love, because I had a whole group of them for the very first time I worked there on the professional development program that we do. And the new lecturers in that case were all teaching the first year, chemistry 1, 2, 3. And over the years, up to now, they started getting moved around, and then they were teaching fluid mechanics the second year. And then they'd come back to me and say, Karen, I've realized that they can't do that stuff that I thought we were addressing in the first year. Then they were teaching reactor design third year and going, oh, wait. So what's happened over the last 7 years is that collaboratively they've developed all these strategies across an entire program using that whole principle of how do we build this in and pull this in and go back. And that's what I want to show you now. So now the test is to see, okay, it's just a reminder of the abstract. So how they pull these things through, and as I said, in our biggest challenge is that what do we mean by application? So, gentlemen, are we ready to go? Is this audio going to play? Is everybody going to hear it? Let's see what happens.
In 2017, as a chemistry team, chemistry lecturing team, we decided to come up with a unit conversions competency test because we noticed certain gaps in our students. First of all, the ability to change between different unit systems and the ability to evaluate the meaning of numbers and the meaning of solutions after solving a problem. And these are things that we take for granted among students, and we expect our students to be able to do this, but we don't actually teach them how to do this. We set up the test to help students to go through a learning process, to practice how to do unit conversions. And we also wanted to instill in students a sense of how important unit conversions actually are. We're referring to, for example, a grasp of different concepts such as physics concepts or chemistry concepts. And what you can see here is some of the classifications. So principle of convention, significant figures, which is something that's also very important within our course. Some of the questions were plain arithmetic questions, which you didn't have to understand the context of the question, you just needed to understand the maths. And then some questions, especially on the estimation side, were questions that related to everyday things which students could understand. And we noticed that there were some questions in the question bank which students coming from certain contexts wouldn't be able to formulate a solution strategy for because they have no context of what the question is. So for example, if you ask a student to estimate the number of ping pong balls in a swimming pool, in an Olympic swimming pool, if a student doesn't know how big an Olympic-sized swimming pool is, it becomes difficult to answer that particular question.
Now, this is step number 1. This has now currently become a 120-part randomized online quiz bank. Low stakes formative assessment. And it only happened because of collaboration among all those lecturers that you saw in that picture. My biggest ambition, Leilani Smith, is to connect this to the bigger initiative, the bigger project. UCT and Stellenbosch have been talking about a shared bank like this, a concept inventory bank, which we can all draw on, which is more contextualized for Africa. And we're talking to Zimbabwe and we're talking to University of Nairobi precisely about some kind of shared platform. Watch the space. Next year I'm applying for funding to be able to do this. And you'll be first on board with me. So that's one way in terms of a kind of technology that is low-stakes formative assessment that we need to enable the students just to practice, this iterative practice, okay? So let's move now into the second year. Now let's go, how do we stretch that conceptual in the epistemic transition into the engineering sciences in COVID-era teaching?
Okay, so what we did, it was a learning opportunity in Chemical Engineering 264, Fluid Mechanics for the second year Chemical Engineering group. Each student was asked to choose an application of fluid mechanics, whether that be in industry, in sport, nature medicine, etc. And then each student had to present in a video format focusing on describing the application and the specific fluid mechanics fundamentals that are at work in the application chosen. Each video was simply a slideshow with a voice recording, and the video lengths were limited to 5 minutes. Each student could use software of their choice to create and edit the videos, although a Microsoft PowerPoint tutorial was provided. The videos were distributed among students within small groups of about 5, and each student's video was viewed and assessed by the 4 peers in their group, as well as one of the module instructors. One of the things that worked very well was giving the students the opportunity to choose their own topic or application. Initially, we asked the students to give 3 potential topics, and we chose the topic that they should focus on, so as to minimize duplicate topics later on when they were divided into groups. By giving the students a choice, we increased the buy-in from their side, because then they would be talking in their presentations about things that they were interested in. And we could also keep the scope or the fields open to allow them to choose any application from any area that they liked, instead of just the typical industry-related examples that they find in the textbooks. So the idea was to get them to start seeing the normal world around them through the eyes of fluid mechanics. And then in the small groups as well, we tried to vary the themes or the fields as much as possible so that each student could be exposed to applications from different contexts. So essentially asking the students themselves to find extra examples to supplement what they see in the textbooks.
Okay, so this one is step number 2 then. So can you imagine by now, with initiatives like this, you've got another kind of concept inventory bank. Now you've got student interpretations, peer assessed and moderated, where you might actually draw from those as alternative localized examples of our students in our context interpreting. You should see these student videos. They are insane in terms of how they've interpreted accurately and seen something, but in something that we can all relate to in our space. This is kind of part of the decolonization trajectory. Help our students to see these concepts and pull them down and apply the appropriate maths, etc., in our space. Now let's make it a little more complex. Now we're going to jump to, and I'm not having my colleague talk about this, she's left us and gone into industry. Now we've got year 3. It's not necessarily as linear as this, it happens earlier, but now we're going to do 2 things. Now we've got process control in a plant-wide process control design kind of space, and we've got 2 things happening. On the one hand, we need to pull it through all this mass and energy conservation stuff down through into plant-wide control design. But I'm going to give them MATLAB and Simulink through which they're going to do this. And they're far away in the last period. We'll talk about that now. Initially, this was there. They in situ in the classroom. And what initially happened, my colleague, Dr. Lydia Oret, who's gone to industry, our loss, their gain, was, you remember our scale now on the wave between concept and context and application? We started working with all of these lecturers on, but what does that mean? What do we mean by application? Now we've got, this is what our very first case study in the curriculum. You could break down, well, for now we've got 5 levels over here. We've already got 10 levels in other spaces, because you can become more and more contextual. For example, even just in the mathematical space over here, you can break that down to the algebraic equivalent, to the geometric, to the representational, as in the schematic of it. That has different levels of concepts behind it and contextual application. And when you start breaking that down, what she realized was that she was teaching initially like this: lecture, tat, prac, 10 weeks, project, go away. it wasn't working because they couldn't pull that through. So what she did was, okay, she realized, remember my little graphic of the kinds of knowledges, that bottom logic-based graphic, they're struggling in the MATLAB Simulink transition space. Let's start there. So we built a model of a plant-wide process kind of system, and students started every single lecture in the computer lab with this model in front of them, and she started scaffolding and identifying one little project element at a time. So she started them down there. Look at what it looks like. This is the bottom of the wave. And slowly then connected it back to the concept she was talking about. So she moved the upward escalator. So she started there. Look at what it looks like. Run the simulation. This is what happens to my output over here. You can already see that we've got a problem with representing just connecting theory to practice on this kind of 2D axis. What she was trying to capture there already in these little bubbles is different kinds of complexity, because there's something else happening here, and I'll get to that in a moment. So she restructured that whole assignment. Instead of giving it to them at the end, she gave it to them right at the beginning. Said, you guys, we're going to be teaching towards being able to do this. And she broke it down into parts. From naive feedback control, single output, little items over there. Here's the big model. Let's just do this, and let's talk about feedback. Let's talk about feed forward. Let's look at disturbances in the system. Slowly but surely, scaffolding over time to the end. One, this took a hell of a lot of work. It took 176 hours to build the model. We had to find the money to pay someone to do it, and the model can't be static. So let's not fool ourselves into thinking it's easy to use the technology to do this. This is really complicated. Even setting up all those electronic simulation online is a mission and takes time. Once it is set up, and if you put your maintenance resources in place, things get easier. We're a little bit in that big swell of too much work in the space. Even after that strategy, though, I'll say I'm going to be a bit later, but I'm stealing 5 more minutes because Prof. Duncan stole 5 minutes of mine. I'm just saying. Okay, when we look at the student's ability to move here from the block diagram space, which is pulling from the mass and energy equations, mass and energy balance equations, okay, and capturing there, into actually running the simulation, being able to work in the simulation space, there was a very interesting thing happening. They're okay up to that level 3. They can pull, remember that first part of the wave, it's almost like the foundation into basic application. But seeing the system as a whole, with all these components and recognizing what I need to do, was still an issue. And the point is, this, what Lydia called the L3, L4 gate, is exactly what we're talking about right now, in terms of the ability to shift into a far more complex paradigm, with kinds of technologies and kinds of strategies that change overnight. And it's the thing that industry keeps telling us we need to do. And the point is, it is about, let me show you. If you type into any browser, type in the word technical skills. First of all, you're going to come up with shortage, gap, not enough. We have major, look at this, reports abound that highlight the lack of basic skills that are required in the digital age. Now, all of that complexity I was talking about earlier, that little bottom graphic of the way in which you're thinking when you're using a tool or technology, it starts even in the workshop with using hand tools, and it goes to power tools, and then it goes to the other digital tools. You can't just throw the tools at them and think they're going to cope. By the time you're hitting them with a platform, how many of you had student problems navigating your online platform? That was huge, and you are one of the most well-resourced institutions in this country, like mine. We ran a survey across our entire faculty, 732 responses, screaming for help in navigating this online space. The lack of consistency, because the navigation as a user, an end user, we need to stop approaching the technologies as though they were science and maths. They might have been created with them. We are expecting ourselves and our students to use them, and they're nothing more than an extension of this exponentially to the factor of power of whatever. It's a tool, and these tools change, and acquiring their habits to learn the tools requires the grasp of different kinds of principles. And that's what we've seen glaring at us in the last 2 years in terms of how our students are doing this. That's what I was trying to show you with that beginning process of you can scaffold towards it. Imagine your randomized online quiz bank in different subject areas that maybe looks different. The principle behind it is the same. Students get to develop that digital fluency by practicing those kinds of foundational things in different kinds of spaces. And you can build that as you go on. The problem here, you guys, is that when we look at the more recent reports, and here, Lelani, this goes straight to your project, and the whole EBIT initiative here that underpins a lot of what Prof. Duncan was highlighting, is the complaint is about, yes, the technical skills as well, the practical skills. Note there, they didn't learn the latest programming languages, but they're missing fundamental or critical soft skills, agile teamwork and communications. Now, all of these skills we're talking about are like that bottom graphic that I tried to explain to you. There are different kinds of knowledge areas in there that come together in different ways under different contexts for different times. Teaching our students to navigate in that space, that's our job. But it means possibly throwing out half of your curriculum if you really want to build the fluency that we're talking about that makes our students agile and flexible. It does mean getting back to International Engineering Alliance, Washington Accord, and ourselves saying what on earth is actually important here. Because the issue is, you guys, nothing changed. This problem is as old as time itself. These are all issues about the same thing. We've been complaining about the lack of technical skills since way before the 1930s. Those were just examples. I went to look at them. We've been moaning about this forever because the trajectory is exponential. We cannot teach them all the programming languages. We cannot teach them all the tools and technologies. But we can teach them how to engage with different ones at different degrees of complexity. It's the complexity that we need to scaffold better. And to do that, let's just go back to our wave for a moment. Let's add an axis. So we're going to add the complexity axis to that connecting theory to practice. And then you end up with something like this, a plane that goes simple but abstract or simple but concrete. Complex and abstract, complex and concrete. And if we go back to what Neo Motang was showing us, let me just go back to that second year module, the fluid mechanics module. By the lecturer seeing, hang on a moment, so pre-COVID, that connecting of the concept to the real world actually happened with a pump and piping prac. Students in groups, competitive, non-assessed, but compulsory, they had to do it. Got buckets and pipes and things that they had to, in a competitive sense, pump water up 5 flights. It was a mind-blowing shift for those students because what happened then was simple things like understanding things like flow rate, things like head, connected with, oh my God, this is what a valve looks like, this is what a motor looks like, okay, in the real world. And then COVID hit and it couldn't be done anymore. So Neo's solution was, okay, make them go to their own simple, concrete, practical things, see the principle and explain to me and to your peers and colleagues what it's about. That was her using technology more effectively, a more complex technology, making videos on their phones and uploading it and compressing it and putting it onto the Moodle workshop platform, etc. Can you see digital fluency developing there like that? But it's a building on this kind of concrete, practical use of a technology, which also builds a kind of fluency, a technological fluency. Very practically, let's go to that third year subject, that big problem with process control. This is from mechatronics, but it's the same thing. He teaches, my colleague Carl Kruger teaches control systems, a lot of the same elements that there are in process control. So by looking at this on this plane, and then with your other axis being over time and developing complexity, imagine that sine wave going through over time, what he did was, okay, that pump and pipe in prac, that little buckets of pipes and valves and motors and things, he built himself a little ball on beam system, okay, a little ball on beam balancing system. Because what he wanted students to see was, okay, here are the effects of control. Because there, with that SpaceX launch and with the control of any, what do you call these things, drones or whatever, we've got a thing called state space control happening in there. But all of that stuff on the bottom, everything that we see over here, is black box stuff. It's invisible. And when we give our students exercises, it's sitting up there, But if we don't scaffold that properly, we don't help them to unpack, well, how does that happen? So what he did, and he's done this 3 years in a row now, he starts in the real world. Here's the complex real thing where you can't really see what's happening underneath this. But let's take, like Lydia did, let's itemize. Siemens has the same approach in their training, by the way. All the Germans have the same approach. Okay, big picture, here's the system. Let's zoom into pulling one part out of a box at a time. Now let's unpack what that looks like. And you take that and you go up here. Okay, let's take that little simple item. Arduino controlled ball on beam system. I can look at the Arduino code and kind of get a sense of the sequence of things maybe. But then I go back into that Simulink, MATLAB Simulink environment, one at a time, and I build iteratively. But what he also did, very effectively using technology, and this is what the LT Spice online stuff accomplishes as well, is in Simscape, he built a little simulation. So two things. I can see my output plot. It's helping me reinforce the mathematics behind what I'm doing. But I can see the simulation. This is what's happening. And that iterative, constant process really started changing how they engaged. But the same as Lydia's experience, start at the beginning. You can't hit them with this complexity at the end, ramping up like this. You need to build towards it. And that building towards it then, in this iterative way, when you take that into the fourth year, that whole approach to teaching like that, my colleague, Professor Christy Dorfling, head of Chemical and Process Engineering, runs the site visit thing, taking these mining and metallurgy students out into real-world sites where they pull all that front-end stuff. Now they see, and here's the difference, the scale is totally different. Industrial equipment is not what you find in a computer lab, and it's certainly not what it looks like on my laptop, okay? And that means, and the people are different. So these students all come back. We've got 2 papers out on this, and it was phenomenal. Process economics, relations between staff on the floor, all of those other complexities, but start making sense because you've already scaffolded this process through. You've built on it, and you've taken, what I hope I've shown you, a kind of a program-wide approach to how do we do this? Because there are lots of wonderful initiatives, but they also sit in silos like our curriculum. I just want to say one last thing about, let's pull this through into that real-world space. And again, it goes back to what Prof. Duncan was talking about. When we're talking about those foundation concepts, we need to start stretching and expanding where we're drawing our theoretical and practical connections from. We have so many rich examples on the continent, for example, of people who've taken what we see as the Einsteins and the Newtons and the whatever of the world. There are other people who've taken those and worked in those spaces. I'm not talking about replacement, I'm talking about supplementing. And in the same way as we can stretch in terms of enhance our graduates' appreciation of these concepts that they're pulling through into practice, we can also pull them into that space. This is precisely what was referred to as enabling that interdisciplinarity, enabling our students. I don't care if it's 4 students from one of your programs, please let's get them next semester just to compare notes on how they're experiencing the same subject in our 2 different contexts. It's a start, okay? Because we need to enrich that cumulative learning wave by drawing on them. And as we know, it takes a village. Sorry, oh, my word has jumped out of line. It says village over there. If we hope to address all these significant challenges we face, it's that whole collective, integrated, pulling together, village type approach that we need to have. Only 5 minutes left. Colleagues, thank you so much. Oh, it's gone. All right, there were references over there. I have made this as a video already, so you can see my YouTube link kind of thing, because I've pulled a lot of them together. I know some of it might have sounded really complex or really challenging. I hope not.
Lauren, a present for you to say thank you that you came all the way from Cape Town. Well, that is the way that you came here, I hope.
Yes, I did come all the way from Cape Town.
To thank you and to say, I enjoyed this. It shows me also in although my own basis is something else than engineering, it makes me understand some of the things that we also make wrong. Thanks a lot. Thank you.
Thank you so much.
Okay, so we're going to take a 5-minute comfort break. We will just make our tea 20 minutes instead of an half hour.
That's what I thought.
It's now 25 to 10. Let's be back by 20. Because
Thank you so much.
Our
Okay, good morning. Welcome back to the first session of talks. I'm Helen Ingalls. I'm chairing this session. And our first speaker is Ridwan Hanslow. He's going to be talking about agile teaching and learning. Thank you.
Good morning, everyone. Don't know about you guys, but I was freezing. I think I lost some body fat in the process. Thank you, Corin, for that amazing talk. I'll try to give something similar to that. I'll use my Alan Gray voice so you guys can think I'm wise, right? So let's go, right? So my topic today, let me just put my timer on. All right, there we go. I have 20 minutes to tell you a story, right? And to convince you it's a good story, right? So agile teaching and learning, quick background. I'm finishing my PhD on project management with agile, and I worked in industry for a number of years using agile as one of many ways of seeing things and getting things done, right? So I have 6, let's call them cards. What is agile? Why agile? What is agile teaching and learning? How to be agile or become agile or think agile, and examples of when I applied agile in my limited time so far as an academic, right? And then when to be agile, right? So what is agile? We hear this word a lot. We heard it this morning as well. It is a mindset. The same way you have a scientific approach to doing things, that's a simple analogy I can give you guys. It's a way of thinking, conducting, processing, doing, behaving, and I'll give you some examples now. So the Agile Manifesto was developed some years back by a group of software developers, engineers, and there's 4 Agiles. There's other principles and other things that's involved, but the 4 values speaks to that mindset, right? So one is individuals and interactions over processes and tools. Working software. Now this is people that done software, so working software might not apply to teaching and learning. Customer collaboration and responding to change. They are over the other things. Now we're not saying those that are on the right are not important, but we think there's more value on the things on the left, all right? So there's many methodologies, methods, frameworks to do agile, right? And this is particularly in software development. However, we do use it. Some people use it for everyday things. Now, this is the Scrum process, right? And give a survey or a year, on average, it is the most adopted agile way of doing things. We call it the framework. It's a project management framework. So as you can see, you do your planning. That's a product backlog, right? You break it up into small achievable chunks within what we call a sprint. It's an iteration. You heard iteration this morning, and it's incremental, right? We produce software. So you see that 24 hours? That's an example of when we tend to talk to each other, when we collaborate, right? That's quite important, right? The sooner you get feedback, the sooner you can pivot, the sooner you can make decisions, the sooner you can spot errors, and the more money you can save, right? And at the end of the sprint, it could be 30 days. More often than not, within industry, we've done it in 2 weeks. In research, we've done it in 1 week. And so you have some deliverable that you guys can then discuss, collaborate on, get feedback, and so on and so forth. I'll give you some examples. So why Agile, right? There's many tools and processes, and there's always new tools and processes and frameworks and stuff that's being developed, right? What makes Agile so special? Let's look at the traditional approach of doing things. It's process-centric. We need to do things like this. Boom, 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 boom. And if things didn't go well because you didn't do this the right way, boom, 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 right? It's more an control management style. Formal communication within silos, right? We know that. There were separate departments, And, oh, you want to give us input, advice, opinions, feedback. Are you even in our department, right? Customer involvement early in the software development lifecycle. So this is obviously emphasizing software. And then as the program or the application goes on and so forth, there's less collaboration with the client, less customer involvement, right? Inadequate feedback mechanisms. I spoke about that just now, right? And then substantial documentation, right? There's tons and tons and tons and tons of documentation. And what you learn is when the application's done, the documentation needs an overhaul, right? So is it really beneficial to invest so much money and manpower into documentation when it does change frequently, right? So let's look at the agile approach. People-centric. Who's developing what for who? Is it not for people? So let's focus on the people. Collaborative, right? If you want to get something done well, let's work together. What's the new motto of research? Collaborative research. Why? Because it doesn't work or it works? Communication is continuous and informal, right? You don't need to set a meeting to discuss to me, Johnny in software engineering, and you in project management, come to me. Let's have a coffee, chill. Let's discuss issues. Continuous customer involvement. The sooner the customer is involved, the sooner the customer can say, hang on, I thought this. Sorry, I did not know what I wanted. Let's recalibrate, right? We know that, which means less issues, less money wasted, less bugs, and so on and so forth. Adequate feedback mechanisms. Like I've mentioned to you, the sooner you guys get feedback, the sooner you can pivot and make adjustments and just provide a better quality service or product. And minimal documentation. Now, we do not say documentation is not important. We say let the documentation align to what you are producing and not the documentation making this amazing example of what the system is, but then the system looks half of what the documentation suggests it is. So as an example is, remember back in the days, business plan, right? Your business plan was the thing that you should polish and no issues and stuff. And then the project or the business doesn't perform as well as predicted, or it fails, so on and so forth. What do we do now, right? As a business coach, I speak to the entrepreneurs, and we do experimentation, similar to Agile. All right, so you think the customers are going to do this, this, and this based on what you think, all right? All right, that's an assumption. Let's do an experiment. Go speak to them. Run a survey. Show them the app. What do they think about what you're doing? All right, it's not what I thought. Okay, let's pivot. Let's change it up. All right, let's change it. That's what we prioritize over documentation these days. All right, so besides that, let's look at the stats, if you're not convinced. Agile is 3 times more likely to succeed than traditional approaches or projects. Now, there's waterfall, spiral, different methods and tools and processes. We do not focus on the tools because they change and the processes change like anything else in life, right? Let's look at traditional, more than 3 times likely to fail than Agile projects. Now, depending on your project, right, if you're investing multi-millions, some countries, billions into technology and stuff, do you want to lose a massive chunk of that? No. So there is a better way to do things, and why not? Let's look at that, right? So what is Agile teaching and learning? I think you must probably know now what it is, right? It's applying the Agile mindset to teaching and learning. That's what it is. So here's an example of an academic that tried to create his own Agile manifesto to teaching and learning. Do you need a chair? Are you sure? Okay. Yeah, I think you need a chair. But you have strong legs. That's good. Okay, so they look at 6 points, right? Again, what we prioritize, what's on the left more than the right. We're not saying what's on the right is not as important, right? Adaptability over prescriptive teaching methods. Collaboration, and I say collaboration, 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 collaboration. Achievement of learning outcomes. Are you getting the students to where they need to be instead of where you think they are going or where you are happy in your happy space. Student-driven inquiry. Are they getting the dots that's being connected, as Karen mentioned? Or are you lecturing for the sake of, I have 2-3 hours I need to spend on lecturing? Demonstration and application, and I love this part. Karen mentioned that as well. Are you taking the abstract and pulling them down to the nitty-gritties? Do they get it? Instead of just throwing them with info. I mean, they can Google that. You don't need to just give them info. And continuous improvement. This is an important point for me. Your success of yesterday won't guarantee your success of today. So you need to reflect, contemplate, iterate, so on and so forth. So how do you be agile? How to be agile? So a lot of these things was also mentioned in today, I think Prof. Duncan as well, right? Flexibility was mentioned. Another word for that's adaptability, agility, focus on the student and not your career, right? Right? Why are you here? Without the students, we would not be teaching. Maybe research, but not teaching. Maybe we teach ourselves and our colleagues, but it's for the students, right? So collaborate, iterate, right? Implement something, do an experiment, and see how it goes in small iterative cycles and increment, right? Are we going to a bigger cause? Receive continuous feedback. Ask the students, hey, can you fill out this questionnaire, or just speak to them. I just speak to them. Hey, how did it go? What do you think could have been improved? What didn't go so well? How would you have done things differently? Listen to them, right? And that ties in with retrospectives, right? So in Scrum, in software development, there's a thing called retrospective meetings. And we then ask ourselves, okay, great. We had the meeting with the client, right? That's the demo. They said this, this, and this. So I think this didn't go so well. Yeah, Johnny, I think so too. Maybe this can be improved. Let's try this for our next cycle. Remember that 30-day thing? That's a cycle. And continuous learning, right? Which is a great thing, right? So I'm going to give some examples of how I try to be agile within my short space in the informatics department. So the first one was for a second-year module. It was a programming module, it still is. The students obviously doing this online, they needed to be engaged, and it's a 2-3 hour long thing on coding. And I mean, let's keep it real now, right? It's taxing on them. So how do I keep them engaged and keep them optimistic and let them learn at the end of the day? Because that's, I mean, why we're doing it. I thought about this fun and games environment, and I put it after the session so that they need to pay attention, but still have fun in the process at the end. So I'm going to show you two students giving feedback on that. Remember, I say I liked my feedback. And the first one is Miss Lali, right? And the other one's Luke.
The long hours of online lectures leave a lot of legroom to get distracted and to disengage, especially INF 272, given that it's a 3-hour-long lecture. But the way Mr. Hansloot delivers lectures, mainly the brownie points during the lectures and the fun and games at the end of the lecture using Kahoot, keep me engaged. You get brownie points for answering questions on related topics covered in previous lectures that are relevant to this lecture. And my favorite part is active recall, or as we like to call it, fun and games, where we compete to answer questions on important aspects of the lecture content for that day. It's more fun to pay attention and in a lecture and retain that knowledge, as you get the opportunity to be a winner in the end. Win or lose, we're all winners as we walk away with the knowledge from today and the excitement for the next lecture.
I think she's a natural, right? What do you think? I think she is. All right, and here's Luke.
Hello, my name is Luke Partridge. I was a student for Mr. Ridwan Hansloot this year in Informatics 272. In the module, he used a new education approach or tool called Kahoot, where it was basically a quiz where at the end of the lesson, there would be 10 questions and all of us had to try and answer, and the faster that you answer, the more points you get, and obviously the more that you answer correctly, the more points that you get. So this created a situation where students were trying to always pay attention throughout the 3-hour-long lesson so that they could pick up any small details and information that could be in the quiz. And every week we would have a high turnover of students coming to the lectures because they wanted to attend the quiz at the end and they wanted to win and beat their classmates and show that they were the best in the class. And this tool was great for keeping our engagement in the long lectures, and it was great for testing our retention of the lectures.
All right. And then for the other example of thinking in an agile mindset was third years, also more advanced programming. And what I thought was they're learning a lot of things, right? And it's taxing on their minds. And you could get the sense, you can get how they respond in the chats and stuff. And then I thought, okay, how can we keep them excited, involved, and not, how can I say, fall backwards? Was then industry preparedness. Tell them about industry, what they're going to do, the job scarcity, as Karen mentioned, and it's a massive problem. Getting to get involved in working in teams, getting soft skills, all these things. And I thought, okay, let's do lectures of my time that I had to do on coding, but let's pivot a bit and let's focus on getting them to see the bigger picture. And then, yes, 2 students as well. All right.
Hi, my name is Thomas. I am a third-year informatics student at the University of Pretoria. I was firstly introduced to Mr. Ridwan Hanslow at the beginning of this year. It was actually his first year at the University of Pretoria, and I was fortunate enough to be one of his first students. He taught us concepts such as Python, Python for data science, and user management and security with APIs. Alongside being an excellent lecturer, Hanslow also took the time to provide us with additional enrichment lectures for those of us wanting to go into industry next year as software developers or anything really in the IT space. I took great interest in these enrichment lectures, and I actually took the opportunity to contact Mr. Hanslow himself regarding these opportunities, and also consulted with him actually at the end of the year outside of university because I was busy with a recruitment project at the time, and I think a good portion of my success or the reason I got the interview can be attributable to Mr. Hanslow and his willingness to help those outside of the university space getting jobs in industry and helping us make that transition.
All right, remember, why are we here? All right, and then the next one, Kiara.
And there's not many people or lecturers that actually inform us of it. And Mr. Ridwan Hanslow actually informed us about industry. With my degree, I thought I could only go into coding and business and system analysis, but it seems that there's various and countless opportunities that I can go into further. One of the ones that actually stood out for me was data science. Now, data science is something that we learned about in our other modules, but you only learn the definition of it. There's no practicality to see what it is like and so forth. However, Mr. Ridwan did show us a few practical examples of what it looks like, and I found my interest in it. And I'd like to thank him so much for having this lecture, because I was able to find an interest in data science, and after my honors degree, I definitely want to go into data science. Thank you so much for your lecture. It was really helpful to me and my peers. Thank you so much.
All right, the focus wasn't on data science and industry preparedness. So again, who are you doing it for? So when to be agile? I'm literally almost done now. Now, what's stopping us from being agile, right? COVID happened. Did we not become agile because of that? So what I'm trying to say is, when you do think of your curriculum, when you do think of your module, when you do think of why you're doing things, think about how best to get the students to where they need to be so they can be ready to be a success in life, right? So, for example, yes, I was in the modules, right? So how can I make it more agile and more successful, hopefully, right? It's always a hope for them. Now, for this year, I'm already thinking, what can I do? What tools can I use so that my modules run smoothly for the better? However, when they go to the next module or the next year, what I taught them, is it the right stepping stone for them to be more successful in the next year? So that's basically the Agile mindset, and I hope you enjoyed my lecture and my seminar. All right, so if you have any questions, please feel free to chat to me. If you want to make the UP way, the Agile teaching and learning way, you can send me an email. I love to collaborate or write papers on these things. So thank you very much.
Thank you so much, Ridwan. Our next speaker is David Wallen from the Graduate School of Technology Management. He's going to be talking about asking, is it possible to create shared identities in online teaching? And he's giving that presentation virtually. So I presume it's going to magically appear on the screen.
So I am here, but it doesn't look like my picture's on the screen. I'm there. I can see my red tie. Okay, so just let me check. Helen, can you hear me? Can everyone hear me? Am I visible? Brilliant. All right, thank you, Helen, and greetings to all the attendees. I want to start by devoting a few seconds of my precious time to Professor van der Merwe for her hard work on the teaching and learning seminar, her encouragement to the staff, and her enthusiasm for pedagogy. Thank you, Alta. Your initiative has made a huge contribution to my academic practice. Today, I'm going to be talking about a subject which has probably been of interest for millennia, changing opinions, changing hearts and minds, and ultimately changing behavior. And in this discussion, I will be drawing on the work of three renowned social scientists, Judith Butler and her ideas on the social construction of identity, Wesley Schultz and his concept of nature connectedness, and finally, Vivian Schmidt on discursive institutionalism. I will, of course, be adding some thoughts of my own, namely the issue of liminality and its application to the student-lecturer interaction. And I will be attempting to bring this all together in the theme for this conference, which is it possible to create a community of practice in the way that we traditionally have through virtual platforms? The context for this research was a cohort of students registered for a master's in energy leadership at the Wits Business School, who I was invited to teach in 2020 and again in earlier this year in 2021. The students were already working, employed in a diversity of sectors, including private energy companies, financial services sector, government, the energy regulator, and higher education. And in those positions, they were responsible for important leadership decisions. They held a diversity of views on energy systems and energy technologies. And my challenge, which I have to say, admit that was a challenge that I set for myself, was to raise their awareness of the importance of sustainability transitions and hopefully to persuade them at the very least of taking decisions that support its goals and principally the uptake of renewable energy. So let me at this point switch to my slide. So I'm going to, hopefully you can see this. Just let me check with the organizers. Can you see my slides? Okay, brilliant. So I'm talking about nurturing liminality in virtual platforms. Is it possible to create shared identities with online teaching? And let me just very briefly describe what is liminality. It's the description of the state of being on the threshold. It's the chrysalis which is between the caterpillar and the butterfly, or between the tadpole and the frog. But more importantly, it's an emotional experience, which is the transition between being uncertain about the future and ambiguous, but simultaneously excited about the expectation of the novel and the unknown. So my hypothesis or proposition is that effective and persuasive teaching can lead to the liminal, And liminality can then evolve to what we call deeper learning or alteration of the personal ideological assemblage. So let me just show this to you in the form of a diagram. This is an EBIT, this is the engineering faculty, and we love diagrams. So at the top, you've got the lecturer, and this diagram comes from Vivian Schmidt and discursive institutionalism. So the lecturer has this background ideational ability, which is the ability to generate ideas, and then obviously a foreground discursive ability, which is the ability to communicate and persuade. So this is a discursive opportunity, if you like. And then at the bottom in the green, you have the student who comes into the lecturers with the background ideology, which I've called the assemblage of normative perspectives, ideas, and ideologies. And that is challenged in the interactive communication between the lecturer and the student. And it's principally mediated through this foreground cognitive flexibility, which essentially refers to the ability to accept new ideas. And so if I just now then come to this issue of liminality, liminality is what may emerge from that communication and what may lead to deeper learning or epistemic change. And in my case, I was particularly interested in a change which provided some directionality towards sustainability transitions and what I've called naturing. So let me talk a little bit about identity and naturing or nature connectedness. And this is now drawing on the work of Judith Butler, who used her understanding of gendering or the process of socialization according to dominant gender norms as a way of understanding identity. And Butler's one of Butler's main conclusions is that to a large extent, individuals act in accordance with cultural norms that are determined for us, not by us. But there's also a recursive relationship between the way in which you behave, the way in which you act. So it's not just a question of ideology, it's how that ideology is translated into behavior. And so identity is a construct which is established through the stylized repetition of acts. And I then sought to adapt this slightly, and I applied it to the issue of naturing or nature connectedness. Something that we also know of in South Africa is ukama, not Ubuntu, but ukama, which is essentially it's the description or the description of the relationship between people and the environment. And so I essentially wanted to conceptualize nature connectedness as being a process which results from a certain pathway, if you like, of socialization. And so it has strong parallels with Butler's work on gendering. So why is this topic important again? I mean, why would we want to reconsider the issue of changing hearts and minds? And I think the main difference is really what has been alerted in terms of the theme of this conference, which is that in our transition to emergency online teaching or virtual platforms, that online teaching offers perhaps a new opportunity for lecturers to engage in this issue of how does one shape the background ideological perspectives of students. And it draws on this notion about behavioral contagion or peer pressure may interfere with the creation of new identities. And so if we now imagine learning as a social process, but in a slightly different way to what we have previously experienced. So virtual teaching may support the development of individual capabilities which are prevented in group sessions. So that was the proposition. And this was actually a bit of research that I then did with the students. And there was, first of all, the intervention. So in the class itself, we had a teaching intervention, and I'll describe that to you in a minute. And then I followed that up with a qualitative study in which I interviewed the students and talked to them using interpretive phenomenological analysis, which I'll call IPA since it's a bit of a tongue twister. So what was the invention? Well, in 2020, I played to them an extract from the Chernobyl documentary, which is pretty horrific. And it kind of, it certainly alerts one to the dangers of nuclear power. And then I asked them these kinds of questions, which is nuclear higher or lower risk than renewable energy? Is it more reliable? Is the benefit of nuclear worth the risk? And is nuclear a better option if you had money to spend on building new capacity? So first of all, in the 2020 intervention, the students were actually quite angry with me. They thought it was highly manipulative. And so I took a much more nuanced approach in 2021, in which I didn't present any material itself, but I played a podcast, which is a debate between a proponent of nuclear power versus a proponent of wind energy. And I polled the students again before and after. And you can see that, in fact, the intervention in both cases in 2020 and 2021, but this is the 2021 results, had the opposite effect to what I had expected, in the sense that students felt that nuclear has a lower risk afterwards than they had presently considered, that it's much more reliable based on the debate, that the benefit is certainly more worth the risk. More students felt that it had a positive benefit to risk ratio afterwards than before, and that nuclear is a good option if you've got some money to spend. So I then went into tried to understand the reasons for this. And so I did the IPA and the qualitative questions. And some of the interesting things that came out of that, and this work is ongoing, so it's not finished, and it's really just an initial study. There's certainly less peer pressure in virtual platforms, but there's also less intimacy. And as a consequence, my own view is that cognitive flexibility is lower than in the face-to-face forum. So students are less willing to change their minds on certain perspectives. The second important point is that there's absolutely no common understanding in the students of the core concept of Okama, or nature connectedness, and the interrelatedness between people and the environment. And I came to this conclusion using the precaution adoption process model, which I'll show you in a minute, but it's just a model around the progression from awareness to taking action. And the final comment was the students didn't feel threatened by the intervention, but it certainly wasn't transformative. Instead, it had the opposite outcome. So this is the precaution adoption process model. If you're not familiar with it, it's a very useful model in designing a questionnaire where you're looking at this issue of the extent to which issues that you may raise as a lecturer have been understood by the students and understood to the extent that they decide to do something in response to that. So it has these 7 stages, and I'm not going to go into those for the interest of time. So in thinking about why my intervention had an opposite effect, I came across some work done in psychology, and there were 2 important insights from psychology. The one is the continued influence effect, and the second is the backfire effect. So the continued influence effect is simply that falsehoods may persist as true in an individual's memory, even though they have been proven false. So this is a well-known effect in psychology, and students persist in their continued influence or in their falsehood simply on the basis because it reinforces their ideological assemblage. So the core really is to be able to change the way in which students think about their core ideological assemblage and what you might call their normative assumptions. And then the backfire effect is exactly what it says. It's a backfire effect. So I think the students perceived of my intervention as trying to change their minds on renewable energy, and that just dug in their heels. So in conclusion, given the importance of sustainability transitions, and I don't need to remind you of that, it's in the news every day. We had a whole week of COP26, 2 weeks, sorry, of COP26. So we certainly need a global dialogue on what works and what doesn't work in the virtual classroom, particularly in the context of sustainability transitions. I think naturing is a useful concept, or nature connectedness, and we have to work on how this connectedness can be enhanced, I think, as a consequence of the way in which we teach. So what have hopefully I persuaded you of my perspective. This has been a liminal moment for you, but of course I wouldn't be so presumptuous, but at least I will have introduced you to a portmanteau of language. So liminality, naturing, nature connectedness, discursive institutionalism, and the precaution adoption process model. So thank you so much. I'm going to stop sharing, go back to you. Hopefully you can see me again. Unfortunately, there's no camera on the audience, so I have no idea whether you've all fallen asleep or not. But Helen, thank you very much for the opportunity, and thank you to Alta for all your hard work on the teaching and learning seminar.
Thank you so much, David. We do have time if anyone has a question, but perhaps people need a little bit more time to just let those words sink in to our deeper learning. Thank you so much, David. That was very interesting. Our last speaker in this session is Caitlin Vinson, who's going to talk about creating community, another way to create community.
I'm going to have to move it down a lot. All right, so I'm one of the faculty advisors for eBITS, and I wouldn't be a good faculty advisor if I didn't advertise us quickly. So when you have problem students, we are the people that want them. When you go, oh, this one again, just forward the email to us and we'll take care of them. So we deal with all those problem students that are really struggling. And so what we realized in a lot of our consultations and when we sat down with meetings is that the students just weren't doing well with COVID, that they were struggling with isolation, they were feeling disengaged, and one of our main concerns was the disengagement from the academics. So a lot of them said things like, oh, I don't do lectures anymore, which they think is okay and we think is really not okay. And so we really wanted to come up with an intervention to address these trends that we saw. So how do I go to the next slide? Oh, they're not showing. Okay, so let's go back. Okay, so we tried, what we wanted to do is we wanted to create an intervention that we'd be able to create community. Okay, so what our aims was to make sure that we could manage and help the students address their stress and anxiety, that we'd promote lecture attendance and engagement with their academic work, that would increase their study time and increase their motivation and mindset towards their studies. So the intervention we came up with was on a platform called Kumo Space, and so we wanted small groups of students so that they'd form connections and be able to network with each other. So we limited each group to 25 or less. They could self-enroll via ClickUp into the different groups. And all of our undergraduate students were invited, and we set it up we structured 4 weeks. So they could enroll for 4 weeks, which we had different topics, and that was obviously on Kumo Space. And so we sent out a Google form to all of them to say, would you like to join a group? And what topics would you like to discuss? And then what times are you available for the groups? And so the results came back that most said that they would like to join a group. The groups that came up the best was that they wanted the topics, and they wanted to talk about balance and holistic wellness, stress management, and motivation. And then we had some fantastic answers, like, when are you available? Anytime, I don't do lectures anymore. Most of them just clicked that they're available anytime, and we wondered why. It kind of confirmed why we were doing this. And so we sent out an announcement on the eBIT undergraduate page, and we invited them all to enroll, and they enrolled, and then we sent them this great thing called a welcome pack, which is actually just a Google form. And in the welcome pack, they had to fill in a bunch of pre-test questions that I'll give you the significant ones now, just the results of the significant ones, and then they had to agree to confidentiality and the housekeeping rules, which basically also just explained how the Kumo Space platform worked. So how do you feel your semester is going? 1's very well, 5's very badly. You can see the curve is not the way we want it. Are you attending lectures? 1 is always, 5 is none. So we've got 20% of our students attending all their lectures, and we kind of want that at 100%. So that was quite concerning for us. Do you feel anxious? 1 is not anxious, 5 is very anxious. That's definitely not the way we want the curve going. And then this one was a bit heartbreaking for us. Do you feel part of the UP community? We had one student that said yes, and the rest said no. They feel completely alone and isolated. And so when we asked them, why do you want to be part of this group? They said things like, I want to be a part of other students who feel the same as me. I want to meet some friends. I feel isolated and lonely. I'm feeling isolated and overwhelmed. I'm not okay and I need help. I'm completely alone and isolated from my peers. I have no motivation. I feel isolated. Isolation kept coming up again and again. And then the last one, I want to believe I'm not the only one struggling. And so I only took snapshots of the first responses that came through, but basically all of the responses that came through repeated the same thing. I'm completely alone, I'm completely isolated. And so we just wanted to create a space for the students to have a platform to talk to each other. Essentially, we wanted to make an online version of eBit Lawns. That was our main aim. So we created an Akumo Space room. So we created 4 rooms, a room for each of the weeks. And so one of the students said it's like Sims 4 but better. And so they really enjoyed the platform, which was great. And so each week had a different room that they could enroll into. And then the rooms allow 30 people. So although we only had 21, and I'm sure you experienced this with your enrollments, 21 students enrolled, 30 students arrived. I don't know how. When I linked up the registration list with the people that actually attended, very few of them correlated, so I don't know how that works. But we realized that the groups of self-enrollment weren't working. More students arrived. So what we did for the first group is we did a yes-no, very unintrusive questions like, is tea better than coffee? Are cats better than dogs? And they either said yes or no. And based on where they were in the room, how Kumo Space works, as you can see, my little CV thing, there's a circle around it. If anyone else is in the circle, they can hear you. If you're outside of the circle, they can't hear you. So everyone that went to the yes group could hear each other, and everyone that went to the no group could hear each other. And then we started asking questions that got slightly more kind of vulnerable. So it started off with is tea better than coffee, that kind of thing. And then we started asking them questions like, what are you studying? What year are you in? And then towards the end, it started getting more personal, like, why did you decide to come to UP? Who supported you in your UP journey? What have your biggest challenges been? What's helped you through these challenges? And it started getting deeper and deeper, and they started connecting a bit more. So that was week 1. Then week 2 was the wellness wheel. So we took the World Health Organization's 5 pillars of wellness, and we broke the group up into smaller groups. And so again, there were 5 different sections that they went through, speaking about their social wellness, emotional wellness, spiritual wellness, physical and academic wellness. And so we also brought in our peer advisors. We have fantastic peer advisors, and they helped manage some of the groups. And then so obviously in academic wellness, we said, are you attending your lectures? What's good about it? Are you spending time working? That one was quite structured, but the others weren't as structured. And then we had the stressless room, and it has the sound of the beach the whole time you're in the room, and it's very fantastic. And we spoke about stress management, what's causing stresses, how to manage them. And this was really fun to see how students manage their stress. A lot of them say series and sleeping, which is completely ineffective because it takes a lot of time and you don't actually feel better afterwards. So it was really great to chat to them about that. And then we had the motivation room, which was the last one. And that was the week before engineering week, so it was very poorly attended, and we thought that maybe the students were so motivated by our last 3 weeks that they were actually studying. Okay, so kind of the results from all of this was that a lot of students gave us feedback that they felt less isolated, because on the platforms, a lot of them were like saying things like, I'm never sleeping, and everyone else was like, me either, I thought I was the only one. We had a lot of first years attend, and I think that they don't know how much work a degree entails. And so they're comparing it to high school, and they're comparing it to what their parents keep saying, like, why are you always studying? And a lot of them spoke about, like, I don't know how people think this is natural. And everyone was saying, oh, we're the same. And so it was really good to see these interactions between the students, kind of what we imagine happens on the eBit Lawns. So they were able to chat to each other and feel less isolated and normalize what they were going through and normalize the fact that they're up at 12 at night and they think they're the only one. And so that was a really great interaction to see. They did also report that they were then more motivated towards their studies because they felt like they weren't the only ones in this boat. They were there with other students that they could say, oh my goodness, this is like, I can't believe this can get harder. We are only in first year. How do we get to third and fourth? And if you're in engineering, sixth and seventh year of your undergraduate degree. And so they started feeling more motivated. We hope that and they said that it made their attendance lecture higher, which is something that we were concerned about. And a lot of them just said they just needed the platform to talk on, and so that was great. So we only had 6 students that attended all 4 weeks the whole way through. So like I said, the last week was very badly attended. And so most of the feedback was that they just enjoyed talking, even if it was talking about, they didn't learn anything, just the debrief and talking was what they needed. There was one honest student here that said it was a bit awkward, because sometimes there was a bit of an awkward silence, but a lot of them said that it was good to feel part of a community, help them feel less isolated, and so they could interact with students online as best they could. And then so we thought it was really successful for at least these 6 students that we had feedback from. But we thought in general it was a good program to run. But some lessons we learned was that we needed to intervene a lot earlier. We intervened between first semester test and second semester test. We used those weeks to intervene. And so it would have been great if we could have predicted this and intervened earlier. The other thing was that the structure was better. We started off, the first week was very structured, so we asked the students lots of questions. And they answered questions the whole time. And they really responded better to the structure than to the non-structure. So we thought in creating community, in creating with these students, we needed to have a lot of structure for them. There was a very high attrition rate. So like I said, the first week there was 30 students. We were like kicking off instructors to try and make space, because Kumo Space only allows you to have 30 students at a time. And so we were completely overwhelmed with the students that arrived. And then the last week we only had 6. So what we ended up doing was allowing students that hadn't enrolled in the self-enroll groups to just join as they wanted. And so some students just joined for one group, which is not what we initially wanted, because we wanted to build that community to have that consistency through, that you'd have the same students interacting with every 4 weeks. But it didn't work like that. And so we ended up in week 3 and 4 just inviting any students that wanted to come that could join. So it was a very high attrition rate, and then we ended up having to remind ourselves that we were doing it for the few, because when the 30 students came, we thought, if we can make an impact on 30 students, that'll be fantastic. And so eventually, only with the 6, we had to remind ourselves that maybe we have impacted the 30, but at least the 6 that continued all 4 weeks through would have definitely had an impact on. And so we had different students every week, so we reached a good number, but those 6 at least we had a very good impact with. So we thought in redoing this, if we're still online next year, we'd do it earlier, and we'd do it with first years so that they can also break up into engineering, IT, and built environments to normalize what it is they're going through. I knew I was the only thing standing between you and tea, so hopefully we've wrapped it up quickly. Yes.
That is absolutely fantastic. Your initiative. I was going to say that it's our conversation about engagement. We need to understand overload, too much work, too much not ready to engage, feeling ashamed, feeling whatever, even postgrads saying I'm just not ready. So we will stop beating ourselves up about that. But what I wanted to say was that we ran the same thing when we picked up first semester A1, that mid-semester test space, where, I mean, just a catastrophe this year, at the beginning of the year. So that's when we did our big survey across the whole faculty, and we recorded, hey? All right. So, no, especially electrical, we see a lot of our ADHD students really battling in some ways because they require the affective space, the other human beings to somehow provide the structure that you're talking about. Nevertheless, so we got data on that. It's a paper that we presented at LEAF last week, Time for Mentally Healthy Engineering Students. But what shocked us was how many went, this is not actually what I signed up for, this is not what I thought engineering was going to be. And I'm really doubting my career choice. And the other thing, in terms of the words to describe the depression and anxiety was so overwhelming that myself and my co-researchers, we weighed through 733 actually qualitative responses. And after every 10, you want to cry. It's so bad. But getting them together, we've now done similar to what you've done. We've actually built, I think it's called the Academic Tools for Success in Engineering, which every student has to enroll for. It's like a module. And we built an online platform covering exactly the same issues that you picked up. And when we printed this up as a poster internally, students had that same thing, oh my word, I'm not alone. Oh, I'm not alone in this, kind of thing. So I'd love to chat to you about that.
Yeah.
Taking it further. I just wanted to say, well done. Don't beat yourselves up for the attrition.
Okay, I've been asked to repeat. Maybe if you can come up and paraphrase for the viewers at home, if that's all right.
Sorry, all you guys online. So, where am I standing? Oh, sorry, everyone online. In a nutshell, Stellenbosch observed the same things, and we tried the same kind of approach, as in reaching out to the students and asking them, what is it you're struggling with? And 733 responses, which were overwhelming. We found a significant number of our students are on serious medication for anxiety and sleep and a whole lot of other things, okay? And a significant number, we're talking about 733 out of a faculty of 4,000, but only half actually clicked on them. So it was a 50% response rate of those who actually received the email, as it were, and actually clicked on it. Point is, serious doubts about this as a career that they've chosen, which says something, first, especially our first years and second years, really doubting what they had selected, crisis of confidence, not feeling equipped, and because it was an anonymous survey, they felt free to express themselves and say how they were feeling, and those feelings were quite shocking to us and the fellow researchers in terms of we felt so disempowered. We got in touch with the counseling services immediately. So we then reached out to the rest of the institution and went, engineering was the only faculty who did this, by the way, because it was so impacting on their work. And so we got counseling services in, and we got all the academic advisors in, and we ran these sessions. We invited students to them to tell them about what was happening. And then waterfall effect, we went down to the HODs, down to program coordinators and this, and said, okay, this is the bigger picture, this is what's happening. I spoke through the research to all of them, and we initiated a similar thing to the Cubospace initiative of just creating a space where students could click on a thing, also Google Form, go, what am I really struggling with the most? Anxiety, click here. Here's a small group workshop, or here are kinds of support, and connecting them together. Also low engagement and high attrition. But the first step was, oh my word, I'm not alone. That in a nutshell is what I was responding to Caitlin's fantastic initiative about. I'm like talking to the mic as though it's the camera. I'm like looking at the mic.
Are there any questions? No? Okay.
Sorry, I see there is a question, but I'm going to ask you to take it up in the tea break. We'll connect in tea break. Thank you so much to all the speakers in this session. The people who are here physically, we're going to ask you to try and come back to the room by about 5 to 11 so that we can start the next session on time at 11. Tea is just outside or up in the restaurant. Thank you so much.
Right. Welcome back, everyone. Welcome to our next section. That's on administering practical work remotely. Let me introduce you to our first speaker, Tanya, and she's going to talk about "And So We Race in Cyberspace."
Okay, thank you very much. Let me just quickly go back to my presentation, which is all gone now. There we are. Okay, ladies and gentlemen, good morning. And what I would like to talk to you about is the almost decade-old robot race now. Next year we will be racing for 10 years, which is, I never thought it would be so long. So what you have here is a lab setup, and that is a dining room table, and we were thinking we couldn't in 2020 do the race. It was just too fast on us, this whole COVID thing, but this year we decided the students miss it, and it's an opportunity that we really want to bring to them. So let me just see, how do you do this? Okay, there we go. We took the little robot cars from the lab into the students' homes, into the dining room, basically. So in this period, I was thinking, how do our students develop? Okay, how do they grow from a first-year student to a fourth-year student? What are the important things that we need to keep in mind when they become engineers starting from a school kid? And that was very important also with the change in the way in which we teach. So the next thing is, what does develop mean? There are different aspects to development. There's the technical skills, theoretical and applied, and then there's also soft skills. And I think we sometimes forget about the students' soft skills. We only try to teach them the academics and the technical skills, but there's a lot of soft skills that they also have to learn. And I'm at the moment in the privileged position where I am actually the mother of one of the students in our department. So I can see this whole process from a totally different perspective. My daughter is now second year electronic engineering, and it has been a journey for me. All that she hears from me is, figure it out. And then she says, Mama. Then I say, but figure it out. Right, so how do students build a soft skill set? So in first year, I think most of our students come to campus and they think, sure, I'm not the only clever kid. I was at school the cleverest kid around, but suddenly there's a lot of other students that's actually quite clever. And I also see, they don't look like me, all of them, because our schools still seem to be quite homogeneous in a sense. And they have to learn to fend for themselves, and they have to understand where do they fit into this whole bigger scheme of things. In second year, they start to interact with their peers, they form groups, they have to get used to getting along irrespective of who or what they are, because they have to work together. In third year, they have to develop social responsibility and accountability towards one another. Now they have to really start working together intensely on a number of things, and they become more mature. In final year, they have to develop a responsibility towards the profession, okay, becoming an independent member of a profession. So that's basically how I see it. So now the technical skills. First year is still a bit like school. Okay, here's your tutorial problems, here's your exam paper, and so on. It's still a bit like that. Basic science foundations and so on. Second year, they transition to sort of inquiry-based learning, start to form learning communities and so on. Third year, very strongly experiential learning with strong peer learning support. And then in fourth year, it becomes self-directive, explorative learning, also with strong peer support, but also then within the context of a mentor, which would be the study leader for the final year's project. And that emulates the working environment. So the practical work, and that is where the problem was now, how do you transition the practical work? Because the module that I present in third year is a very practical module. So in the first year, students are introduced to the laboratory equipment and just how to work with that, which is obviously a problem. Second year, they do a little bit more complex experiments and they're introduced to design. Third year, there's a guided design with experiments that they have to use for validation, and then in final year, they have to do independent design in their final year project. So basically, if you look at the third year package of skills, and that is where I am now, I am a third year lecturer, they need strong experiential learning. They need to develop social responsibility towards their peers and forge interpersonal relationships, and they have to have this guided design with the experiments for validation. So that's the little package that we have to give to them still in spite of online learning. So just to look at experiential learning, so the definition given by Boston University Center for Teaching and Learning is it's an engaged learning process whereby students learn by doing and by reflecting on experience. And that is exactly what this robot car project has always been about, giving students an opportunity to be creative, to work in teams, to solve problems that they haven't encountered before, to apply what they learn physically, to see where they fail, to learn how to deal with failure, and so on. I think most of you are familiar with the robot car, so I'm not going to go into too much detail about that. So we decided this year we couldn't have the race event, which is the final practical event of this module, as always, and we decided to take this whole thing online. So all the practicals, everything was administered online. We shipped components to the students, or they collected it, so they had all the component kits with them, but most of that competition part of the project was administered online with all the semi-finals and quarterfinals and so on online, and then an in-person final event. And there was a Facebook page. I was so glad for the marketing team of the faculty because I'm Facebook illiterate. So they managed all of that, so that was quite fun. You can still have a look there if you want to. Ooh, I hope I can play this video for you. So if you take experiential learning online, the first and biggest problem is resources. How to get all the resources to the students, and equally, if you can put it that way, because some students have a lot of money at home, some students don't. So you have to still level the playing field in some way to allow students to learn equally and to benefit equally from the opportunity. So we rely heavily on industry for sponsorships of components, and then of course it's difficult if you put students in teams, the location and all those kind of things. In fact, we have now last year motivated for the second years from this year to get USB oscilloscopes that they have at home, so some lab equipment. They've used it this year because my daughter was second year. Yeah, it made a world's difference. They could do so much more at home than what they could have done before they had this equipment. Let me quickly introduce you to one of the teams. I'll talk about this as we go along, but I'll play you these little videos in between. Let's hope the sound works. I don't think the sound is working, but it doesn't matter. So they have all these sounds and everything going with. So the students had to present these little videos online, and that was posted to Facebook. And you can see the initiative and the creativity, you know. So they really went to a lot of trouble making these little videos. I'll see if I can sort out the sound for the next one for you. But yeah. But let me just go a little bit. Yeah, so the creativity is incredible. People always think that engineers are these boring people that don't have any creativity at all, and you can see it's simply not true. Yeah, so I'll try to sort out the sound for the next one. Okay. Okay. Oh, there they go with a very fast algorithm showing off their engineering ingenuity. Right. Okay. Let me just see if I can skip this one. Let's go to the next one. Okay. So the soft skills that I need are sort of developing me and the people around me, peer society, be the dependable one that the others that can be trusted. They have to seriously collaborate. They have to communicate. They have to delegate. They have to pick up the slack if somebody in the group doesn't do their job. That's a very difficult thing for students to learn, but that's very important. But how do you do this online? We basically decided just to put them in teams, wherever they are. Port Elizabeth, Pretoria, wherever, they're going into teams and they have to work together. They had to learn presentation skills. They had to learn to deal with distance isolation, not being able to see whether your pal is actually doing what he's promising, okay? Dealing with all that, and obviously dropping a teammate if you never looked him or her in the eyes is very easy. Oh, I'm not just, this is not working for me, I'm not doing this anymore. That is very difficult, and students really had trouble dealing with this, but I think they developed a lot of skills that they would otherwise not have been able to do. Being in groups also provided peer support in this context, so I think it helped a lot for them not to feel so isolated. Yeah, right. The Morph rover, let me see, was this is also a video. I'm just quickly going to see whether the sound is actually on. It seems like it. Let me just go back. Yeah. Okay, never mind. Let me just quickly go on. Okay, okay. Just no down still. So there's the Morph rover there.
Try again.
From current slide. Okay, right. You think the sound is going to work now? It doesn't sound like it. Yeah. Okay, never mind. Doesn't really matter. You can go to the Facebook page and then you can see all these little videos with all the sound. Okay, but you can see how much fun they had making these videos and just being creative while doing it, while working really very hard. It's always fun at the real race when you say, ladies and gentlemen, start your engines, and it's a big thing and everything, and then these little cars go tick, 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 tick. So in any case, so there you can see the Morph rover going. Let me just see, I'm not going to play through all of it. Yeah, and you can see the dining room table and they have their practice. You can see I created tracks that I could print out on A4 papers and stick them together so that they can do this at home. Okay, so let's go to the next one. So we rely very heavily also on a scaffolded design. So they designed their Morph, and Morph stands for Microcontroller-Based Autonomous Robotic Vehicle, and they call them their Morphs, in 3 practicals. So I broke it down into 3 practicals. So the first one is the sort of the communication protocols, and then it's the sensors and so on. And then there's tutors in the labs and demonstrations where you can help them and so on. So all of that was now kind of gone online. So how do you scaffold design online? I wrote a textbook for them that integrates all of this. So you can see there, practical 1 about comms and testing, and there's the chapters about what they need to do that. Practical 2, and this whole textbook is online for them, and it's written specifically for this project, okay? With all the interesting things that I would see in their little cars. So the challenge remained, We had our tutors online, we had online demonstrations, and it actually worked quite well. There is another one, and this one is as interesting. Oh, yes, I can just do that. You can see, again, the creativity here, and these guys were very interested in, what's that movie, Back to the Future? So they had this Back to the Future theme, where they, I have some snippets in here. Without the sound, it's definitely not so spectacular. But there it goes. You see how fast it goes? Very, very extremely fast. You just wait a little bit for it to get around the Hanekromme. So a couple of years ago, this toy turn, the students first, they were laughing when I get into the lab, and then I'll ask them, what's this about? And then eventually they came out, no, but that's the Hanekromme. There it pauses the DeLorean, and there you see the fun that they had with these little videos. Okay, we enjoyed it so much, I can't tell you. But in any case, and then we had these little jokes. So it's a PIC microprocessor, and the one student then said, I don't think I'm using this right. That was on the Telegram group, that. And then one of our assistant lecturers is actually playing in a band, so he recorded this video for them, and I'm so sorry that I can't play the sound for you, but he played it with a PIC, and he said to them, it's just for instructional purposes, take note of the orientation and so on. So we really had a lot of fun online that we would not have had we been in class. So you see he's teaching them how to do it properly. And this last little video I can't play for you really, also because it doesn't have sound, but it was made by one of the tutors for the module that really was so involved and enthusiastic about this whole thing. There you can see this was our in-person event only with the final teams. So the winners and the guys with the coolest car, they had the fish tank, that you can see there. There are two fish and it's a tank. So they really enjoyed that. So one of the nice things about this is also that we actually integrate this into our whole curriculum. It just spread over the years. I mean, it's almost 10 years now. So academically, we have at least 3 other modules integrated with this vertically. So in ERS 220, that's this digital design or digital systems module. They start on the navigation system. In ENE 310, they design the sensor. The design modules where Dr. Badenhorst sitting at the back there has been involved this year. They take the car further and then they make it go into a maze. But now they have something that they're familiar with and they can now learn proper design principles. I just make them do it, okay, for the fun. I don't teach them design principles, I teach them microcontrollers. But then poor old Werner has to teach them proper design principles. And then it also goes into the community because the robot race itself is a public event, so many people can attend and school kids and so on. And we usually get all the students anybody who wants to volunteer from the department. So it kind of feels like family, the whole department going into this event. And then that JCP module, we integrated that with EPY 423, which is the Work Integrated Learning module. So in the Work Integrated Learning module, the 4th years designed a robot platform drawing from this experience for a robot school that we presented to school kids this year. And the JCP, the 2nd years, they were then the instructors. So the 4th years would teach the 2nd years to present the lessons to the school kids. So it's a whole thing. But it's actually integrated all over. Right, and finally, with 1 minute and 21 seconds left, this is us packing the components ready for shipping for this module. And that's where I'm going to end. Thank you very much. Class size, I have usually between 280 and 320 students. It's massive. I put them in teams of 4, but they can decide whether they want to be in a team of 1. That's not quite a team, right? But some students, yeah, so I leave them. They decide how they want to do it. But so say 65 to 85 groups. Every student. I tell them, you go sleep with your pick kid, you go breakfast with your pick kid, that's your new girlfriend and your new boyfriend. Yes. Every student. Okay, any other questions?
Right, quick technology break. Thank you very much, Tanya. The marketing for this event across the social media of the university was quite visible, and it would really add value for you to go and have a look at those videos. I looked at some of the videos, watched some of the videos on Facebook, and really well done, and it looked like a lot of fun. So thank you for that. Our next speaker we're going to continue with our theme, and this is about decentralizing the academic practical work around the country. Our next speaker, Chloe.
Hello, everyone. I'm just gonna do this. Yeah. My name is Chloe Mukobodi, and I'll be presenting to you guys just an idea that I have, and I think it will be relevant for this workshop. But it's just because of the progress that we've made as human beings into the future, or currently as we were pushed by the COVID, but it's not really COVID, it has been going there. So online learning. So we have here the outline of my presentation, and I'm glad that I've seen few pictures in the presentation that came earlier on with people holding hands. I think that is a key. And then I just happen also to have it. And I think I also just wrote a few things that I got from the other presenters. Prof. Duncan, innovation, Dr. Karin, practical and embedded. And we also had speakers talking about collaboration and flexibility. So I'll take you through what I have for you. And it's not gonna be a long one, but I hope it does touch us and then make us start thinking in a way that will prepare us into the future. So education, basically throughout the history, it's just, it was initially something that was not formal, but it was formalized. But I think it was a good thing because we need to learn from the people that lived and then improve from what they've seen. But it's just a key that we use formally to connect what we already know to what we are striving to as the species, because I think we are one of the species that continuously try to develop. from the previous method to the current methods, we've moved from the centralized education system, and then now we are trying to get away from getting together to facilitate education, which is now online facilities, which we are all aware of. We've been speaking about those the whole morning. And the one thing I need to emphasize is that technology made it possible for us to achieve that. So electricity, electronics, and our internet, which is one of the things that we are happy to have, and it's an advantage. But in the spectrum of education, you need both theory and practical, because the idea behind it is that you need to prepare people to be able to deal with practical situations and solve practical problems. But they should first go through theoretical approach. And then these are just a few things that I observed, which I think, this thing feels like it's far. I observed, they are not based on a lot of detailed research, but these are just the observations. We are going to encounter problems with the migration. As I say, we are migrating to online, and we are also going to have a lot of benefits. Like currently we have an online session running in parallel with this. So if we want it to work, because the truth is that we are going in that direction, we need to embrace what we are benefiting out of that. And this is going to level the field of play for people who are, we are in Africa, we are in South Africa, we know the problems that we are dealing with at a general level. So one of the things that we can benefit out of this migration is that most of the people that do not get to the centralized model of education might also benefit from decentralizing education. So that is what I mean by leveling the field. And then there we are going to be able to facilitate education online, and this process is deemed economical based on other aspects that we as a country or as Africa we have those problems, and I think it's for the majority. So maybe I also know that our Chancellor also spoke about that when we migrate, we need not have to leave anyone behind. And basically, we need to take those that cannot be as fast as the rest. So in migrating to online space, what we are going to save on, it might be cost, but the idea behind this idea of decentralizing practical work so that we can all have access to it is that we have already infrastructure, and Prof. Duncan spoke about building or just transforming the current ones into something that can be usable once we enter the space of online. Okay, we know that theory is very vital, so is practical, and theory is viable only online. And when you get to practical, some of the things you might not be able to cut away, even though you progress as deep as possible into the future. Those are embedded deep into us as a species. So I just give an example there, saying that imagine you have to be in a situation you are asked to learn how to swim online and then go to practice swimming straight from there. It's literally, you cannot achieve that. So we need the practical. So how are we going to achieve that in the case that we fully migrate on to online? And I think in that space, you need to be able to understand that you are not going to be able to take away certain things, and then you need to be able to manage them. But practical work forms a major link between what we are trying to achieve using the practical or the education system. Basically, it just stands, in the education system, you're trying to prepare the students into becoming adults, into the economy, and participate into that space. So it forms that important link, which you have seen with the other presentations that we have had the whole morning, that, okay, there's there's a chain here, and we are following a chain. And the problem that I'm trying to give to the brightest minds in our land is that how are we gonna transform fully online and still make sure that we carry the practical aspect of education? Okay, so we need to understand that practical work is important, and we need to prepare to manage that. And we also need to be able, we spoke about hybrid models, which will also be just another aspect of the problem that we need to look at. And you can appreciate that we are going to have huge problems, and the solution to those problems will not be for us to say these are huge for us. We need to confront them and come up with somehow solutions. Okay. The current state of affairs, here I'm just looking at the education system and its intent and how are we gonna achieve that. On your left, you have just the primary or preface, and then primary as you go and you graduate, and then you enter the working environment. But all the graduates, somebody in the morning also spoke about our employee, I think it was Prof. Duncan. We need to be able to employ our graduates all over the world now. So it is going, by the time you get to all over the world, I think it is only viable that you are able to deal with that same problem in a country setup or provincial setup or something like that. Deal with it in a small scale and then escalate it. The same way with theory, practical and real world problems. But basically education, when you look at it, if you have an engineer graduating from University of Cape Town and an engineer graduating from University of Venda, you should have same qualities in those engineers if you are planning to deploy them in the world that we are living in. Because you don't want a situation where you say this engineer is better than this engineer. Therefore, that being the case, it says that all the universities should be facilitating comparable type of work or curriculums. So the learning outcomes as in engineering, let's look at EXA. Those are the outcomes which are set by the body that governs all the engineers, meaning that our universities should be able to produce the same quality, if I can put it that way, of engineers that go out. So if the universities are actually delivering that currently, which they should be delivering, then we shouldn't have a problem in transforming or having this idea of decentralizing practical work around the country. Which the idea is that we need to, because we are going online, students are learning from home, and because of cost, which is one of the problems that we have in the country, maybe the cost of education, as Prof. Duncan indicated. For that reason, as you are solving this mystery problem, you need to be able to also look into the fact of cost. So we have infrastructure, building infrastructure, and for the past 20 months, we haven't used those for anything. And the next question is that if we fully, in the future, go online, how are we going to deal with the fact that students are at home, but we still need to facilitate them with practical work? So the idea behind this is that we just take all the infrastructure that we have and we transform it, improve it, and then make sure that all the students can actually attend in their respective provinces or cities or regions. It is possible because all the students that we have currently are, when we were in the centralized space, they were able to attend. They were able to attend the practical work in their respective campuses, but that came at a cost. And you don't want to have a situation where your students need to travel just for practical and then they need to attend online just for theory work. So you need to keep them where, in a way, you are taking practical work or full package of education, practical and theory, to the students, close to the student. The viable solution will be to transform what we have now, which will be cheaper for the universities. It will also be cheaper for the students as well, because you don't want education to be an expensive commodity that they need to get. So, because we also have a problem with our economy, and then I think it's a problem that we all know. And the idea behind this, again, about transforming the education system around the country, it feels like it can be overwhelming, but with the technology that I just also touched on, that we have good, actually, methods that we have in place, we can use those to manage our students ultimately, so that we can be able to achieve this. So I'm just thinking, imagine you have a student coming from University of Pretoria or registered with the University of Pretoria and the other with Wits University. These two students need to be exactly the same, but now they have to attend practical session in one facility somewhere because of where they are located. That will also help, because students where they are located, if they learn from where they are located, they are most likely going to start developing that part of the country, which is basically going to help in a long run. So in conclusion to this talk that I had for you guys, to decentralize the economy, our focus must be directed on all the aspects. As the economy is busy decentralizing, we don't have the economic hubs as we had previously, because we are working from home. So we can as well look into also making sure that education is also taken along, we take it along. The decentralizing education system, successful on both the theoretical and practical, it's going to be something that we need to achieve. And this will bring education to the doorsteps of the people that cannot get to where it is in the space of centralized education system. This will also strengthen our collaboration, where we don't compete but we collaborate. That is one of the things that I think we also need to look at as universities, because our mandate is not a competition, but to have students which are capable of helping the world, if I can put it that way, and retaining the students in their own regions so that they can develop their own regions. Because we can see that we have dense cities because of the economical activities happening in the cities. But if you start decentralizing economy, then you want to start decentralizing the education system so that they can also develop where they come from. And it's just a matter of when, not because it's going to happen whether we want it or not. So it's just for us to start preparing for when it happens while we still have time. And in the case that we cannot achieve that, we are going to have even bigger problems than we have right now. And I think that is everything that I had to share with you guys. And then if we can, but I don't think we have time. But I think I have 5 minutes. Oh, okay. So I was just thinking we can discuss it, not to question why we cannot achieve it, rather just to how can we achieve it. Yeah.
See, I'm an outsider. Sorry, everybody. I was going to say it's a fantastic initiative, and I see you and I connected on LinkedIn in any case, because we've spoken before. UNISA tried to accomplish this 10 years ago when I worked for them. Precisely this whole issue of hubs, technical hubs. And we started the conversation with EXA and with these people. The wheels turned very slowly in that space. But there are companies who do want to come on board. The Festo bus, they want to give us a bus in every province with, for example, process automation related equipment. So there is possibility here, but it takes a bigger pulling, driving initiative. And I want to tell you right now, we need to pick up this conversation going forward, because it is doable, but we have been trying it for 10 years, even with NRF funding, and it just gets stalled in the terrible administrative processes. but I think it's an important initiative.
Thank you. Any point? So, yes. Okay. Okay. Thank you, everyone.
Thank you very much. I'll just stand on my toes for this one. We keep have to adjusting the microphone. But our final, thank you, our final presentation in the session has two speakers, Helen and Aubrey, and they're going to talk about designing meaningful video practicals with a very catchy title, What is the Pressure in a Soda Can?
Thank you so much. I'm Helen Ingalls. This presentation and this work was done together with my colleague Aubrey Oberholster, and he's attending virtually, so I've told him he can answer all the difficult questions. So I feel a little bit intimidated after all the amazing presentations we've seen so far today. And what I'm talking about is a very small intervention that I did in my class, but I'm operating on the principle that it's better to do one small change than to do nothing. So I'm talking about quite a small change. And this is a change in how we did the practical for structural mechanics, the third-year course in structural mechanics that I teach and Aubrey has helped me with. And the benefit of having Aubrey come in is that he came in this year and he's very good experimentally, which I'm not so good experimentally. So this is what we had before 2020. This is our strain gauge practical. We have a compulsory practical in the module. It's an EXA requirement. And we have an angled beam experiencing a combination of bending and torsion, which are measured with strain gauges. And so we have a couple of key components in this practical. There's a relationship between the abstracted representation and the actual setup. And in those red circles is where the strain gauges are. Then we have data collection. Again, with the strain gauge setup, you collect the information from the strain gauge. Maybe I should explain what a strain gauge is for those of you who aren't mechanical engineers. The idea, strain is the change in dimension. So it's a change in length divided by an initial length. So it's a measure of how much the body deforms. And a strain gauge is a tiny foil structure that's a long, thin wire that, as the structure deforms, the wire gets longer and thinner, and so its resistance goes up. And so you can measure that change in resistance and relate it to a change in strain. And in order to measure these very tiny changes in voltage caused by these changes in resistance, you use a thing called a Wheatstone bridge, which is this, I don't know, does that show? No, it doesn't. This way here of connecting 4 strain gauges to amplify the signal. And so we've got this abstracted representation of the Wheatstone bridge, but all of that is already captured. So we've got this box, which is the strain gauge indicator. The wires are plugged in, and as far as the students are concerned, it's a black box. They don't understand how it works in this practical. So this is how the student participation was in the pracs in the past. The students could, these are some photos from student projects, the student could add weights. There you can see one of the weights getting ready to be hung on. The students could capture details of the geometry and the setup. So here we see students trying to take a photo underneath to see where the strain gauges are underneath. And they could read off the strain gauge readings from the strain indicator. So it was an in-person practical, but there were groups of 15 students. They had a 30-minute time slot because I have 300 students in the class. So due to the group size, I mean, if you're in a group of 15 students standing around that small thing, you can't really see very much. They didn't really have time or opportunity to explore the setup, and they weren't actively involved in setting it up. They arrived, it was set up, they hung the weights, they took the readings. This is not an authentic practical experience. And so I had felt for a while that this wasn't an authentic practical experience, but I also hadn't really got over the hump of trying to make myself change it. And then we moved to online teaching. So now I couldn't use this old prac. The physical practical was no longer possible. And so this was the incentive that I needed to reconceptualize and redesign the practical. And I was helped in realizing this redesigned practical by the fact that Aubrey came on board with a great deal of experimental expertise. So in thinking about the redesigned practical, and I thought, trying to think about what are the key elements that we want from a meaningful practical. The first thing we want is we want students to get an exposure to the kind of experimental techniques that they're going to use in their final year project, in their industry practical life. We want to reinforce the theory that we do in class. I mean, it's really important that we do all this maths, we do all these equations, F equals ma, sigma equals E epsilon, except not in my class because stress is a three-dimensional concept, but we've got all these equations, and we need to show the relationship to the real world. These equations actually describe what happens in the real world. They're not just equations in a textbook, but they relate to the real world, and that helps us to understand the theory that we're doing better. It's really important that the practical be in a relatable context, that it's something that we can identify with. We want students to do data analysis. Those are some of the skills that we're measuring in the experimental outcome, experimental investigations outcome. And the other thing about real practicals, we want to reinforce the theory, but we also want to introduce them to the ideas of experimental uncertainty. It's not always as clear as we think it is, and the dots don't always fall on the straight line. So what are the uncertainties? What can go wrong? So we thought about this, and the practical that we came up with is to investigate the pressure in a soda can. And we're doing two practicals. The one uses the experimental technique of digital image correlation, which is where we take photos of the undeformed and the deformed can, and there's a digital process to subtract those photos to calculate the displacement field. And the second is the one I talked about, the strain gauges. So in designing the practical, I thought through, and here's my very messy notes, thought through the topics that are in the first part of the class. The other thing is I want the practical to happen early in the class, early in the course, so that there's time for students to have understood the material, to complete the practical, to reflect, rather than having it late when they don't do it because it's a rush and they're studying for exams. And so the benefit of this practical as we conceptualized it is we start by calculating strains from a displacement field in the digital image correlation component of the prac, which relates to those 3D concepts of strain. We calculate strains also from measured voltage changes in strain gauges, and that relates to the topic that we have on strain gauges. We use strain transformation to go from the strain gauge readings to components of strain, and that's the strain transformation component of the class. We calculate stresses from the strain, so that relates to the constitutive relations work that they do. We then transform those stresses to calculate principal stresses, and once we calculate principal stresses, we have an expectation of how those stresses should be aligned because we have theory, and so we can also calculate the misalignment angle. Are those strain gauges aligned the way we thought they were, or is there a misalignment? And finally, we can calculate what the pressure is in a soda can, in the pressurized can, which we can also compare with values from the internet because this is a fairly well studied phenomenon, and so I can get some independent validation. So that was the design of the prac, and I was really happy that we're managing to incorporate all these components into one practical. We had two components of the prac, and for each of them what happened is we generated a unique data set. Well, it wasn't completely unique. We have 300 students. We made 30 data sets. Students received them. They received an Excel sheet. When they typed in their student number, it spat out a data set. So they each got a sort of unique data set. They submitted their calculated answers via Google Forms, and so those calculated answers could be auto-marked using a rubric, and I know the people from electrical engineering are going to talk about much more fancy auto marking, but this is our mechanical engineering version of auto marking. And then they also submitted written answers using Turnitin on our learning manual on Blackboard, which were marked by the teaching assistant. So there was a calculation component and then a reflection and component. So here is the benefits of doing the video prac is that actually you can get students, this isn't very close, but this is the digital image correlation, and that white spot is where the light is pointing to take those photos, which then generate this image of the displacement field at the right. So students can get much closer in the video than they could have in the old days when they were in a group of 15, kind of standing at the back trying to peer over someone and not get tripped up by the classmate who's not paying attention. We learned some lessons from Practical One. And the first lesson is, I mean, as Karen said in her presentation and other people have spoken about, it is very time consuming to develop these kind of resources. We also learned, so Aubrey's an expert in using digital image correlation, and he was very surprised by how difficult it was to get uniform displacement fields. We were expecting to get nice uniform displacement fields because we've got this nice simple model of the can, but the real world is not as simple as our nice simple models. And so Aubrey struggled quite a lot to get the kind of data that we could give to students that would help to reinforce the concepts of the class, as opposed to just, wow, the world is complicated. So that was unexpected. And then the last thing we learned from this first prac is we released the memo for how we marked the calculated answers, which unfortunately means we can't do the same prac next year. But maybe we can change something and do a similar prac. So the second prac, we did not release the memo. The second prac, is with the strain gauges, and here are screenshots from the videos that were developed. And the benefit of this is that applying strain gauge is actually quite a sophisticated and time-consuming process. The students could observe the whole process of preparing the specimen, and potentially if they were going to use strain gauges themselves, they could use this as guidance for how they would do it in practice. So a much more authentic experience of working with strain gauges than arriving and seeing it already stuck on. So I think this gives increased learning of the methods than compared to what we had before. These are the examples from the results that were given. So the other benefit of what's it called, the affordance of the digital media is you can then zoom in on that screen and show this is the strain readings, this is the voltage readings from the unopened can, and on the right we have the voltage readings from the opened can. The voltage readings are negative. The change in voltage is negative because the can has become depressurized when we opened it. And so they got their data set, but this was to understand where their data set came from. So I think there are some things that I'm really pleased with about this prac. Although students didn't participate hands-on in the prac, the application was familiar and accessible. All of them could, at home, take a can, open it, do it. You can't, at home, measure the strains on your can. Perhaps if I get connection to Tanya's kits, maybe we can develop some strain gauge things that they can do at home. But you can at least understand the context of what's happening in the prac, which is one of the big difficulties we're having with doing online learning. We introduced students to experimental methods they'll use in the final year, and I think they have a better understanding of how strain gauges are installed and used. We also, which was my key outcome, demonstrated a range of important theoretical concepts in the course. They analyzed real, almost real, experimental data. We started with real data and then perturbed it to create the sets. But they had to do that data analysis from the beginning through to the end, work through that process, understand. Then they could calculate the misalignment angle, they could investigate sensitivity to error. So we also asked them to think about if the results were not what they expected, what what did they think would have caused those changes? What would have happened with a 5% error in estimating the thickness or the Young's modulus or the strain or the alignment? What do they think caused those effects? So that's what I have for you today. Thank you very much. We have to get our exercise.
Okay, so my question is a simple yes/no question almost, and it links to Tanya's, what you said about their kids. Does it make sense to create a kind of a kit for these students that one can use for more experiments and that will then build up to their end-year projects in the 4th year as well? Thank you.
I'm going to let Tanya come up. It does make sense, but yes, it does make sense, but it requires you to have quite a lot of integration and planning. So Lilani, we're going to be integrating, right? But clearly, I mean, what you've showed is that with those years of laying that foundation, that can be quite valuable. I don't know if you want to comment.
Yes, well, last year, when we had to send the kids, the students, they're still kids actually, I'm thinking of mine, home to do a practical at home, replacing the robot core, I sent them home to build a breathing monitor. And I was just thinking about this because you can actually build a type of a strain gauge at home, and the students did that with tin foil and so on. So that could be done. Whether it's accurate enough for that specific practical might be a question, but I suppose, you know, you can do pressure in the lungs or something. That's a huge displacement, something like that. But you need the equipment to connect to that. So the sensor is one thing, but you need a lot more. And I don't know in the mechanical engineering program whether that is viable. However, there might be place to integrate also among disciplines. So we can think about that.
Alta always gives us
Helen,
Sorry? Oh, Aubrey. Aubrey, over to you.
Yeah, just something like Arduino. You do get a module that does reach completion. So that is a cheap option that could be available.
Maybe we must talk with the EIR people because our students take that module. Now we're getting complicated. Do you want to yes?
Last question, I think.
Oh yeah, I forgot this. With the practicals, can we maybe have a situation where we allow the student to generate their own memos, and then because they are if we break them down, just to see if because I think they also think differently or they will observe different things especially on practicals.
I mean, so the issue of memos is a thorny issue. And I've had lots of discussions with people over the years. There are some lecturers who firmly believe that students should not get memos because once you've released the memo, then everyone has it, especially in our subjects where there's a right and wrong answer. There are other people who say if you don't give them memos, they'll just work from bad memos. So if you give them good memos, then at least it's an even playing field. And so I think there's a lot of discussion back and forth. So it's partly a question of, my course for homeworks and tests, the memo gets released. And for the homeworks, I don't change the homeworks very much year to year because who has the time? But the students then have to manage it themselves. If they want to look at the memo instead of taking the opportunity to learn, then that's their thing. Something like a prac where it's very high setup cost, and if I give them the memo, in this case was an Excel spreadsheet that had all the calculations in it, that then next year they can do it without doing the thinking. So that's the trade-off we're always trying to work with, is how do we create the space where they have to struggle with the thing they don't understand, but then they get the help to see how it worked. Now, I don't know that I have the right answer for that.
Okay, a very special thank you to all speakers for an excellent session. Sorry, Robert, was there another question? No, let's quickly... no, we don't have time. Apologies. But thank you very much to all speakers for an excellent session, and over to the next chair.
Okay, ladies and gentlemen, then we start with the next session, and that will be on assessment with technology. And I'm going to introduce you to Vukosi Marivati. I hope I pronounced that correctly. You can correct me now. Thank you very much.
No. Yeah. No, there's no audio.
Okay, you sure?
Yeah, no, sure. All right. Good afternoon, officially. I'm Vukosi. I'm the chair of data science in the computer science department. This is the first time giving a presentation like this, so slightly nervous and anxious. But I wanted to talk about two pieces of technology that are connected to Python. One being NB Grader, and the other one being Streamlit. So NB Grader for building online assessment that is on top of coding, and that could automatically grade for you, but then get students to have scaffolding, so they can build very complex, actually, assignments by having scaffolding. And then Streamlit, when you get students to work on projects, they can then focus on the methods or the algorithms or the things you want them to learn, and then they can actually build quick proof of concept tools that they can actually give to other people. So this is through 3 courses that I teach, one being MIT 804, which is optimization for the big data science masters, NB Grader for that, Course 802, which is natural language processing for data scientists, and then MIT 808, which is the big data science capstone. I'll make sure I think. So let's start with Jupyter Notebooks and NB Grader. So Jupyter is an environment that gives you almost like notebooks that you can build your Python programs on. So instead of writing code and then getting it to run, you get the notebook, and then from the notebook you can run it cell by cell on that. I'll give an NB Grader runs on top of that. What it allows you to do is that you can set homeworks or assignments where you remove pieces of code, and then you require the students then to fill in the missing pieces by themselves. So you can test for specific concepts that they understand them, and then they write the code for that on there. And then what you can do is that you can do auto-grading for some parts of it. So you can have tests that run once they submit back the notebooks. Or you can also have manual grading where you look at their writing. So they evaluate something, they look at an experiment, they run it themselves, and then after that they then talk about what they were actually able to see. So the reason I had to use my own computer is that I'm going to try this thing of doing live demo, which is always very dangerous. And this part, so this is what NB Grader looks like. So this is for MIT 804. You see I had one homework, which was in 5 parts. The nice thing I like about NB Grader, I teach the MIT in big data science. We typically have, let's say, block lectures, 1 lecture a month. But the students in between the lectures have 5 assignments that they have to work on every week. They're submitting something on there. So that's just how the view is from NB Grader. Now here's the homework. So we're just starting off. This one is, hey, for the students are coming from different faculties and different backgrounds. So how do you introduce them to Python and get them to focus on the concepts, on the algorithms, as opposed to the code, right? So this is supposed to be the first assignment that just gets them comfortable with the environment of using Jupyter notebooks, and it goes through. You can see I write nice little notes for them of what are they going to be doing in this homework. They're going to be learning about some packages, which is NumPy, which is for numerical computing in Python, and then we generate some data for them. And then here on this section, hey, there's a fitness function that they must think. So they're trying to do an optimization. So they have to write a fitness function that is described here mathematically. On here, they have to write it in code, right? And you can see here it says begin solution. When this notebook gets converted into the homework, it removes this piece there. The student has to be the one that actually writes it out. And then after that, they then also have to they'll have some tests that they can see just to say, if you write the fitness function correctly, these tests should pass. If they don't pass, there's something wrong, go fix it. But there's also hidden tests that I've written for myself. So they can't go and hard code a solution because my tests will run separately on there, and then those will also be hidden on that part. Then it goes in, you can do things like visualizations, so it shows if they've written the thing correctly, it will visualize it and then show it to, it keeps on giving them feedback, so to that conversation about memos and not memos. In this case, at least, they kind of construct the memo themselves as they're going through the homework, and then finally, they write their first algorithm, so you see this is a very big chunk of code, but then they are going to focus on one part. They will have a description that goes before here of what they're supposed to be, what's the input, what are they supposed to then do on that part, and then there'll be parts that they have to then write themselves on this part as the first scaffolding. So if they finish the first assignment, they should be comfortable with, I need to abstract away the code, I don't need to worry about Python, I just need to understand the mathematical concepts, and then I implement them on that part. So this we've done, we've done this is the instructor side. Then you press, there's a little button there that says generate the homework. It generates it, and then now this is what it looks like. So they'll put in their name, they'll put in their student number, and then if we scroll down, these parts were there, you'll see, it will say your code here, right? And then they'll have to write that code themselves on that part. It will only show them the test functions, the three, the other ones now are hidden, they won't see it. They finish this, they send it back to me. I then do grading. Sorry, let me just quickly try to remember. So what they get, for example, this is on ClickUp. Here's the homeworks. This was part 1 and part 2. Some instructions on how to run it. They can run it locally on their own computer, or they can use Google Colab. So Google has a free environment that runs on their own virtual machines on this part. So this now reduces the point of you need to have a very powerful computer. You basically just need to have a web browser. As long as the student has a web browser and they're on the internet, they can then do the homework from anywhere and on this part. And Google's environment is a standard data science environment, so almost all the packages that we need are already installed. They just need to open it. It starts up a little virtual machine, and then they go. So what does this look like? We're really going to be going live. They get access to this folder on our Google Drive infrastructure here at the university, and then you can then just go in and say, oh, I just want to open with, and it will say Google Collaboratory. That's a Google Colab environment. It's already integrated. I don't need to do any extra things on there. When that opens in Google Colab, that's what it looks like. Exactly the same thing as what I had on NB Grader, but now it's running on Google's infrastructure. Right, so they can run this. You can just click here. Okay, I should not do that. Connect, and it'll allocate a new machine somewhere in the world. I don't know where, and then it will say we're running, and that's it. Once it's connected, they can then go through, and they've got a whole Python environment that's already on the internet that they can use. It'll say initializing and then connected. On there, they can do the homework in here. Once they have finished running everything, they just say download as IPYNB. On ClickUp, they just submit that file into ClickUp. I download that file, which now, I download that file and then I run all the whole, from ClickUp, I download all of the assignments. There's a bit of fuzzy matching of the name. They have to, write the file name in a specific way. I run the autograde. The autograder checks it, knows here's a student number, gets that, the date, and then which assignment it was. From there, it runs the autograder. This is just an example, MB grader, autograde homework 3-1. It goes through all of the assignments where there's tests, runs the hidden tests, and actually reruns everything. And then from there, I go back to this, let me just check. It then gives you an interface where it says, oh, do you want to now provide the mark? So for the ones where it did test and there was a mark, it will automatically give them a mark. Then there's going to be places where it says I have to manually mark, meaning that I've either asked them to discuss something that they've seen, and then I'll put in, I'll give them a grade and then either write notes on that part. So I could see their code, then they've had a failure, and then I can write a note there saying, oh, this is why you had a mistake here on that part. So here, they've written their solution to the thing. You can see this a little bit more. Mine was 1 line, but they wrote it in 3. That is fine. It passes the test as it were. And then my hidden tests now also run in the autograder on that part. So that's another part. So this is very nice, and it really, for me, has made it easier to provide homeworks in this space of, we have a master's program that's through Bullock Lectures, but I don't need to focus on the classes, those 1 hour, as being the place where they learn. The students actually spend most of their time learning in between the lectures by having access to these and actually going through all these concepts. And this, like for example, this is for course 802, which is a natural language processing one. You can see we have like a 1 hour engagement, and then they always have an activity that they then have to do afterwards. And this activity is literally every week on ClickUp, automatic, hey, here's your next section of the homework. Here's your next section on the homework. And what I've noted is that the students now are like very much looking forward to the notebooks. Because now in the class, I go through kind of the intuition of a lot of the approaches and the methodologies that we use in the area. And then in the homeworks, they get to actually implement and try them out and explore how they break them, and also then come up with new ideas, to the point where yesterday we were having the exhibition for course 802. So the students actually did projects themselves, and then and this is one of the students who said, really, the notebooks were great for learning the practical in such a way that they could now do research level projects for course 802, all right? So you can actually go to this website, I'll have the website, and see there's 13 presentations. All of them, I was actually amazed at the level, and this has been building up for the last 3 years now, saying if we get the notebooks right, the students become very comfortable in now asking research questions, right? The practical part is now abstracted away. It's think about the research that you want to do and then continue on there. Now, that's NB Grader, and then if people want to talk about that anytime, I'm very open, because there are maybe ideas of how we can work with the IT team at university to make it easier to integrate with Blackboard and everything. At the moment, I do everything literally on my laptop, and it's a few extra steps that are in there. The other part now is just imagine the students do the methods, they come up with an idea. How do you get them to build something that can be prototypable and given to a third person? On this part. And this is where now I want to talk about Streamlit. So Streamlit, again, it's another Python tool, and it allows you then to deploy almost web apps with just 1 line, right? So it's almost like you install Streamlit, and then Streamlit, you run your app, and that's it. What does this, why is this important? I go to MIT A2H, which is our big data science capstone project for our Masters in Big Data Science. So in Masters in Big Data Science, these are all of our partners. These are different EBIT and NAS departments that are working with us, and they then either have their own elective courses or have specific research that they want to do within these spaces. In year 1 of the Masters, it's classes that provide the core skills, and they do some electives from advanced, and then the preparation for research. In the second year, there's 2 parts. A capstone project where the students take everything they've learned in year 1 into an end-to-end starting with the problem all the way to providing a solution on there. And then they have a mini dissertation, which is the research project. So we're going to focus on the capstone project. So in the capstone project, the way we designed it is the students have to work with a partner who comes most of the time from inside the university, who's interested in a data science approach to a problem that they have. So one of the big partners we have is FABI. So I'll give an example. FABI, we want to be able to identify if a forest has an infestation of specific beetles. What we have is satellite imagery. We have a lot of satellite imagery. We have specific with timestamp, and we know when there was an infestation and not. How can we use machine learning or AI to be able to identify this automatically? That was the question. The students will get that question, get the raw data, and have to work for 3 months to come up with a solution, right, on that part. So they have to kind of, but so the thing that FABI wants or needs really is the proof of concept. They don't want the finicky, here's like, you know, how the algorithm works inside. But the students will work on that. And that's why kind of we use Streamlit. So these are, if you go on each of these links, you can then find the exhibitions of the different projects, okay, on that part. So in the data science process, I'll use this one, you typically have to go through all those different pieces. And then the part that we're very interested in is in the presentation, the proof of concept tool on there. And as such, Streamlit allows us then to build on some of these. So for example, this is just one project I worked on with some students at the CSIR. The students have, we've built some machine learning models. And in these machine learning models, you load your model and then it has to classify something, a piece of text. So if that, works correctly, you then have a news classifier that's on here, and then you can paste text inside there and it will classify the news. This one is in Setswana or Sepedi on that part. But then in the background, they worked on the models and they built the models, and now you have a web app. In the same way with MIT 808, we had students who then built a system for COVID-19, I think news classification, sorry, as I said, live demos. And in the same way, they build a thing, they put it inside a GitHub repo, I'll show it to you. It runs the system and it gets it to run, and then it builds a web app very quickly. The students can focus just on building their methods and sorting out what they need to sort out. And as just Python code, but then this then converts it into a web application as they need. Then what they do is they provide GitHub repos that then, for example, this one here, where it describes the project, they've worked kind of on their data, their notebooks that they've built during the time, any other code, and then they have the Streamlit application that's on there, and you will see they will have, hey, here's how you get the Streamlit application to work, and then this one also has a nice little video that shows you how the Streamlit actually, and it's a GIF, that shows you how that Streamlit application actually works on that part. So you can go from the methodology, the algorithm, and the approach, and all the way to a web app that they can then give to another department, and they can test it out and go like, oh, this actually solves our problem. And if that department now wants to go apply for grant funding or get funding from a partner to say, let's actually get software developers to go through there, you've now transitioned from just the data scientists, but then moving into something that can then expand the thing. But then this is also built around teaching and learning from the students themselves. So yeah, that's pretty much it. Wow. Good.
With this fantastic work that I don't see too many questions. Anybody? There's a question. Thank you so much.
So first of all, because I've sent you a connection right now, thank you. I need to ask something. In terms of the setup, let's talk about return on investment, cost-benefit analysis, in terms of, just give us some insight into that, preparing all of this in all of these environments in the current times.
Yeah. Sure. If I go back, the first, I think, with MIT 804, we started, for NB Grader was 3 years ago. At that time, coming up with the first homeworks was tough. And because I was thinking about it, I spent some time during my PhD shadowing the vice president at Rutgers University, who was thinking about Coursera and Udacity at the time. They use similar, they have their own notebook system on that part. So I knew how the systems work, but then coming up with the homeworks is not easy. So it meant going in and actually taking some of these classes myself that are on these other platforms and going, oh, this is how you come up with. And there's a community now. You can sign up for mailing lists of people who are trying to use NB Grader and all those ways. But since then, the year-to-year investment is zero. All I need to, like, even though I showed you like one of the assignments, I change the function every year, so it's not the same one. They can't. The function is easy. You're just changing a mathematical equation, and they have to program it. I test it, and you're gone, and you move on. For the COS 802 with the NLP one, that's a little bit tougher because the methods are much more computationally expensive, so they have to use Google's one. They have to use GPUs, and that one is harder to change, but it's my research area, so that cost, I take it almost as zero. It means I learn a new thing every year that I need to go in, and then they play around with GPUs. Streamlit, it's completely to the students. So what tends to happen is that the students have either to use Shiny in R, or they use Streamlit in Python. So I've liked Python because then once it's done, it's easy to package, and Streamlit just got a lot of money to actually do this because they've become such a big company, even though it's completely open source. They've become a big company and they got a lot of money to keep on doing this because it allows data scientists to interact with almost the rest of a business without showing, we like the technical stuff. We want to show them the nice little, business doesn't care. And in the same way, science doesn't care, right? Science is like, okay, can you show us ultimately what we can do in our science? And that's why with MIT 808, we found that it's a great opportunity for the rest of the university to experience data science in their space because the students are required to transfer that. So the students are the ones who deal with the setup, but it's part of the class that they have to actually do. So we just give them some links to here's how to learn about Streamlit or to learn about RShiny. They work on it themselves. Yeah.
Thank you very much for that. I think something that one also has to remember is there is so many resources available, and one should actually be casting an eye over the internet just to see what is available that you can use in your classes instead of reinventing the wheel. So in our department, we do like reinventing the wheel or maybe inventing a new wheel. So Dr. Werner Badenhorst will be talking to us about using parameterization within our department's assessment management system to create assessments with unique parameters for each student.
Good afternoon. Almost lunch, don't worry. Poor Prof. Craig is going to do the last one before lunch. All right, so perhaps just there are a lot of words in the title. What do I mean first with parameterization? The idea is that you've got the same problem in a question paper, but the parameters that define the values in the problem is a unique set for every student. So that's what we wanted to aim for. Mr. Hans Grobler is not here today. As I told her, I think if you had Pinky in the brain, he'd be the brain. I'd be Pinky. So he's the one that actually created the whole AMS system. So I think 2015, I started evaluating spreadsheets using MATLAB. And some of my colleagues had other systems. And then Hans came and he built everything into this amazing management system that we have in our department. So why do we want to do parameterization? That was my biggest concern, is exactly that. So can you, by changing the parameters, prevent them from cheating? No, because they can still sit in the background and compare the methodology behind solving the problem, but now it just takes a bit more time because they can't compare answers. Everybody's going to get a unique answer, and it eats away in their time. So it doesn't prevent the cheating, it just makes cheating a bit more effort, and you try to limit it. So maybe from the outset I can say that I found that the statistics in terms of the courses that I did compared to pre-COVID is pretty much the same in terms of throughput or the exam results. So I'm pretty confident at least it helped some. All right, so just a quick word on what our AMS or our system does. So it's Python-based. I'm not a programmer. I'm an electrical engineer. So programming, I'll show you right at the end where my happy space is. It's not programming, but I have to do it. All right, so we can evaluate pretty much any type of question with that system. So there's nothing we can't evaluate. But most importantly, the true value of the system is that I have in my third-year machines course is you've got a complex system where you've got a model of a transformer hooked up to a model of an induction motor, and there are certain parameters available, but there are, I think in the one question there were 10 permutations that you could follow to get to the final answer. How do you evaluate something like that? How do you mark with a student's mistake? If he makes a mistake up here, how do you follow through? So this system allows us to solve for that type of thing. So we do that through a spreadsheet. If it's on campus and it's a class of 500, then we have to use optical code recognition sheets that we've also specifically designed. I just want to give you, as I'm going to talk about the system and how we implement it, I just want to give you first of a background of what the student sees. So on one student side, this is my student list, this is my view. When a student enters his course, this is now, for example, just want to go back one, student view. Right, so the student gets a whole list of all his assessments. So in my courses, all my assessments, pracs, tats, everything is done on this system. So the student gets his list of assessments. At the bottom of the page, there's all the marks is uploaded, so he can track his semester mark throughout the semester as the assessments are released. I'm going to focus a bit more on the exam version. So when the student comes into the exam, all the times, this is the upload and download times that's allowed. After evaluation, he gets the marking rubric. Once the exam starts, he can't see any of this yet. What he does come into is the assessment files that he and she can then download. So the question paper, that's generic, but there are no parameter values in that question paper. It's only variable names in the question paper. You've got some data sheets and equation sheets, even though it's open book. I try to confuse them as much as possible by providing as much as possible equations. They, after all, need to know how to use it. And then they get every student gets a unique spreadsheet that then contains the parameter values that they need to fill out, that we're going to have a look at just now. Right, so this is the environment where the student goes in. We're now going to talk about what sits behind all of this. I need this one. So let's start with a very simple one that I used in the second year course. I know the mechanical guys also take this in the second semester, metallurgical chemical. So here we only have two parameters that I want to be able to change the values, a K and a theta 2, and we want to vary those between students. So what the student gets in his or her spreadsheet is in the green. I've set it up that there are the parameter values that's specific to that student, and the student will enter his or her answers in the yellow block. How do we vary those values? And this is now where the code starts in. But I'm mostly engineer, so I'm assuming most of you have got programming background. All right, so the Python is on the right, the English is on the left. So we define the question. The first thing that the system does is to go and check the first time you run the marking script, is to go and see, have I already defined parameters for this test set? And it extracts. If it doesn't find anything, then it doesn't exist yet. And then in this block, it actually goes and creates those values. So I just decided on 5 different values. It chooses any of those 5. For K, it chooses any of the 5 for theta 2. And then it writes it into a dictionary. It writes it into a database. The next time I run the code, it's already in the database. And for that specific student, for that specific question, it extracts those values from the database. I then assign the values to the variables that I want to mark in my code, and then right at the bottom there, in the student's marking log, I'll show you just now what that is, I write it back to the student. So then the student, if I maybe slipped up, well, if you slipped up at this stage, you've got big problems. You don't want his spreadsheet to say one thing in his marking log another thing. You're going to have big problems then. Right, so in the marking log of the student, this is now after the evaluation, I tell him, this is the values that you've gotten, well, which will be the same as what he got in his spreadsheet, but that's just a confirmation for him while he's going through his marking. I'll say, oh yeah, these are the values that I had to work through. How do I use these then? Because now, programming your memorandum, there's no fixed answers. So your whole memo is programmed. The entire solution to the program is written in code. So I'll show you an example of that just now. So now in the student's feedback, the marking log is his feedback, is the memorandum. I tell him, so the first parameter he had to go and calculate was the reactive power, and this is how I used those two parameter values to get to the answer that you should have gotten. The student's answer I extracted is 1020, so he would have gotten his marks. The complete solution here at the bottom, I know it's very small, you don't have to read it, but this is the complete feedback that the students get just on the marking. So the big advantage of the AMS is you get so much feedback, the student knows exactly how you marked that paper. There's no, well, that's if they read, which we know is a problem. Then they'll know exactly how we marked. The big reason for the AMS, and maybe regressing a little bit, but it's important to understand this concept because this is where the parameterization really needs a lot of programming. So this is the example that I mentioned about a transformer model. So you've got the transformer model on the left, you've got an induction motor model on the right, but there are multiple paths that the students can follow. So what I typically do is I draw out the paths, and I need to be able to assess. Doesn't matter what method the student followed, it's a valid method, and it needs to mark for it. So that takes a bit of programming. So in this parameterization case, this problem is a bit complex. You can't go and just vary each variable, just choose a random value. You're going to end up with unsolvable problems here. So you have to carefully design each problem, and I created, for this case, 5 sets of data. So there's 5 possible sets. This specific one that I've got here is E. These are all the variables that's entailed in this specific problem. The transformer for the motor. This is, I call it test set E. But within each set, I can vary a bit. I could have chosen more values there, but it's not necessary. They usually can't solve this problem anyway, so I don't need to vary too much. You can work in some parameterization inside, but now I've got 5 test sets, and I can vary a little bit on the inside. So how does that happen in terms of the background? So again, when I run the evaluation code or the marking script, it checks, does the values exist? Has it been created in the database? If not, choose set A, B, C, D, or E, and then it then jumps to the bottom of my code where all of this is sitting. It extracts that data, and it then assigns it to this variable parameter, and I assign it to the variables. That's the easy bit. But now, having chosen values, different sets, it's going to create a different outcome for each test. So part of this parameterization is a design section. So now I have to take these selected values, solve the problem, and make sure it's a valid solution. But in this process, I'm actually creating more variables that's unique to that student that he's going to need in solving the problem. So that's what this section does, and it actually then writes those values into the database as well. Next time the student comes around or the marking script is run, all of this has already been done. Okay, so what does the student see? So this is what happens in the background. What does the student see? First step, now let's hope Excel works. Now I wonder where is it going to open? I'll say, kom mee. Right, so I have to start off with a spreadsheet, and you can see it's a rather lengthy spreadsheet. I want to go to this specific question that I'm busy with. So there's my, that's 5.1. I have to create a blank spreadsheet into which all of this is going to go. So this is just a blank spreadsheet. This is not what the student sees yet. Before that, I have to create a template spreadsheet, and this is now where Mr. Grobler comes in and getting all this to work. I have to define where each specific parameter needs to be written into that spreadsheet. Mr. Grobler's machine will make sure that I need to make sure that what I type into my spreadsheet, the variable names, are exactly as I defined it in Python. And then Mr. Grobler's machine puts it into the spreadsheet. So what does the student see? He sees a nice, clean submission spreadsheet with all his variables written in there uniquely. The pain of this system, and what I don't like, is you've got the question paper on one hand and the parameters on something else. And I like it to be all on the diagram. So the next phase would be actually, I'm not looking up to that one, is so that you can actually, when you create the PDF file, it writes it into the PDF as well. If I think about that, I'm happy with this again. I'll be somebody else can be the guinea pig. I'm not gonna go that route. But that would be the ideal scenario. Then each student gets his complete question paper with everything on there already. The last example that I want to, this is the marking script. So remember those, let me just go back one. All these different paths that you need to take to mark for a possible scenario. So on the left is marking for just the developed power. There's 1, 2, 3, 4 possible options. And then there's another variable in the same question with 1, 2, 3 possible options. So your code gets quite lengthy, and then you probably don't believe me that I don't like programming, hey? So, so this takes a lot of time to design, but yeah, what we won't do to make sure the students don't cheat too much. The advantage of this is I can't, even with parameterization or not, there's no way I can evaluate a student each solution uniquely, all those steps. Then it's either sorry, but it's right or it's wrong. But now at least I can mark partially. I can decide, do I want to give you half marks for after the first mistake, or after 2 mistakes, then I stop marking. But at least now if a question counts 20 marks and he makes a mistake at the beginning, I don't penalize you all the way. Right, so this has nothing to do with the parameterization. The big thing is that you can still, this is the feedback the student gets. So initially, I think I've zoomed in a little bit, the answer should have been 1581. So I have to calculate based on the student's parameter values. 5 minutes, thank you. Is that now 5 of the 15 or the 20? 5 of the 20. Thanks. And then I program in the memo. So I tell the student, here's the equation that you had to use. The student should have gotten 158. He put in 165, which I don't know how he got. The system tries every possible angle of what it could, but to no avail, he still got 0. All right, the last one I want to talk about is an EIR. So the mechanical guys will understand this. This is a second order differential system. You want different values for the voltages, the resistors, the capacitors, and the student needs to solve the bottom. You can't just plug in any values. You need to make sure I want this to be an underdamped system. So I need to design those values to allow me to get a specific system. So the student gets nice clean values. He doesn't know how much design sits behind it. I have to choose an inductor value. That dictates what my equivalent resistance needs to be. The equivalent resistance is the sum of 2 resistors, so I can choose the equivalent resistance, one of 5 values, which I've pre-designed. Then based on that, R2 has a certain constraint in terms of values, and once I've got R2, that will dictate R3, which in turn will dictate the capacitance to ensure that it's an underdamped system, and then I can write the values into the spreadsheet. So there's a lot of design that goes beforehand before you can setting up the question, but if you can design it, you can program it. That's my view. Right, and then the student, in the end, he just gets his values again of that specific system that's been designed in his marking log, and that's it. All right, I had to put in this picture. It's in your program. That's me in my happy space. That's me right there in the machines lab with the students getting our hands dirty instead of sitting behind a PC and programming all this stuff. So this would have been much nicer. I think this is 7 years ago. All right, thank you very much.
Thank you very much, Werner. Any questions? I must say this is an, you might ask why all the programming, but it's lovely once it runs. If you want to regrade something, you change something, and it's a question of milliseconds, and a class of 300 students, question papers are graded again. So there's certain advantages. 600 or 600 or 800, some of our classes are 800, yeah. Right.
It's really easy to actually put things in a PDF if you know how. That is my exam I'm working on. That's the memorandum generated automatically.
Oh, that's Professor Warren. Yeah, thank you. We know.
Yeah, he's the guinea pig.
Yeah, he's the guinea pig. Yes. Any other questions?
Mm. Okay. So the question is on how do you administer the test. So it's almost like ClickUp, the AMS, all the students, it's our system. So the students log on to the system, that GUI that I showed you. They go to their specific course, click on the assessment, all the files are there. They download the files, the same system, they upload the spreadsheet, and that goes into the system, and we mark from there. We've got our complete own assessment management system now. Yeah. Okay, yeah. Yeah.
Okay, thank you very much, Werner, for that quick run through our IMS. It is really a very powerful system. Yeah. Right, so our last speaker before we go to lunch is Professor Ken Craig, and he will be speaking to us about online assessment using tools from Google, Microsoft, and Acrobat, which is very important. I think we forget how much we can actually benefit from all those tools. So thank you, we're looking forward to that.
Okay, good afternoon. My name is Ken, otherwise known as the person between you and lunch, as I've been reminded. Yeah, it's interesting how I'm also one of these who want, well, I guess we were all forced to do our own thing. Initially, when the pandemic hit, sorry, this is the first time in 2 years that I've been in front of an audience. So it feels a bit strange. But anyway, so we kind of thrown in the deep end, figure out, the next class is next week, what are you going to do? So that's where this started. So I just want to share more the practical way that I went through and then applied into other modules, second semester last year, first semester this year. So it did save quite a bit of time. So this is, practical to-do list, sort of what happened to me. Okay, so there are 3 parts to the talk. Basically, the 3 softwares, Google Forms, Excel, and then Adobe. How they helped manage the whole system, some automatic marking, but more, I'm not a great believer in just having an automatic test and not really knowing if each student, what they did and how they got to the answers. I think there always has to be some kind of handwritten piece to it, which obviously can maybe be done with OCR, but you'll struggle with, I think we can qualify as pharmacists because of our ability to read handwriting. So the 3 parts I think will become clear, but yeah, so to start with the Google Forms, we all migrated to Gmail. Can you still remember how it was before Gmail? The university has this ability to sometimes link into software platforms, and then we have to work with it, but I think we're in a good space now. So once you're there, obviously you have all the Google suite of stuff available to you. And forms I didn't know before this, so maybe first go there. Yeah, so I was co-teaching with Alani at that stage, and she knew somebody in electronic engineering, where it seems like everything innovative comes from, as you've heard. So yeah, I knew about forms. Prof. van der Merwe likes always sends us forms to do this, so I knew they existed, but I didn't know that they were actually quite a useful tool. So I got a template from Lelani, and then I started from there to learn what you can do. So obviously, you can do multiple choice, different types of answers, and also file uploads, which I think opened the door. Okay, so hopefully you all know what forms are. I mean, they just something there on. If you click on those 9 dots, you get a purple thing at the bottom somewhere. Okay, and so once you've set up one and you've made it general enough, you can just reuse it, as a template for the next one. So that's what happened, and they get saved under Google Drive, and I did not realize, and some students also made this mistake, that you've got a personal Gmail since whenever, and now you've got this university account. And sometimes you don't look at the picture at the top there, which ones you are logged into, and then you're saving the forms responses to the wrong, to your personal account, and then to get those things migrated across was a bit of a headache in the beginning. So just stay clean when you do university work, I guess. Same with calendars. You can sync them, and after a while you don't know, where did you make this meeting? Was it your personal or work Gmail account? Okay, so we were forced then, decided then to use it early on in the semester and then subsequent semesters as well, because the students also have to learn about this platform. I forgot to start that timer, but that's okay, I'll watch. So we first did quizzes, so no stress environment, just submit something, a quick quiz. Then class test, similar, just multiple choice, immediate feedback with an automatic marking or near immediate feedback. And then try and do some uploads, so you have to take a picture or scan something. So you went from people just taking pictures to others using the laptop, MacBook thing via their father's server, cloud back, 10 plus megabyte pictures, trying to upload a simple handwritten script. So we had the whole spectrum of learning curves for students to figure out how to do that. And then we were ready to use that in the semester test. I could bypass the unwritten university. Oh, this is recorded, right? Oh, sorry. Back in the 90s, we had to go and do a course, a formal education course, how to do multiple tests, multiple choice, and you can only do 20%, I think, maximum of your semester test. So yeah, I won't say what the percentages were that I could do now. Anyway, so we mixed basically a mix, and then also in the exam. And the nice thing about this is that you could use your computer, tablet, smartphone, your friend's phone, doesn't matter. You just log on to Google Forms. So I think it was a lot more accessible, even especially in load shedding. Okay, as long as batteries lasted. But students struggled with this thing that you have to upload things. So, like I said, they took pictures. So Cam Scanner, for instance, I guess it does a kind of a JPEG or some kind of Fourier series analysis of what's written and what's not written, and so it's a compact, couple of 100 kilobytes of a page. So you don't need these big internet connectivity. If just learn. So that took a while for some students. Okay, so I then also use the forms for register. So when they get into the exam, first 30 minutes they have to submit this. So I know they're there, they're connected, they can upload, confirm their presence, just like the yellow strips that they fill in the exam. So you can say, if you didn't submit in the first 30 minutes, out of here, you're too late. And we also have then a signature and handwriting to compare for the uploaded stuff. Okay, so that only came in later, not the first semester, but later when I realized I can also do this. So then I make them used to, it looks like an exam paper, it always looks the same. My email is there, they can ask me questions during the exam. I know who they are by their email address, they can't fake that. There's like a formal title page. I do the university's regulation of, this is, I'm not going to cheat, that we have to put in. I then also say I will be honorable in my work, the honor code, they again have to agree, so it's like you can say they will cheat, but they have to say twice that I won't. So sometimes that might stick or not. But we have to assume that they're innocent and honorable, I think, always. And then there's some more identifiers that because that you can figure out when people do cheat and there's the wrong email address, you can at least have another place you can check who they are. Okay, so then I have different forms for each question. In the beginning, I try to put everything in one long form, and then obviously at the end they're going to upload, and then the upload fails, and then they got 0, or there's rewrites or whatever. So this way, I don't believe in my colleagues who say, you've got so much time, end of question 1, done. Now we start question 2. That's not how I wrote my exams. I often went back to different questions and later remember something or whatever. So I think we need to keep that in online. So they've got these multiple forms. They can choose which ones they want to answer first. They can upload separately, build confidence, because it's a lot of stress for them to do this upload thing, connectivity and things like that. Once they struggle, they can email me, and then I have at least a record that they did struggle. I can see all the time while they're writing how it's going with the different questions, who's uploaded already. So it's like a live dashboard. It gives me, and I'm allowing multiple submissions. I mark them all because I give them the benefit of the doubt, and that's how I picked up some cheating as well, which wasn't my intention. So and then they also get email back from the form. You've done this successfully. That also puts them at ease. There's a timestamp. I know exactly when they submitted. This I don't know how to control, but Google Forms every now and then it's got this gotcha, catcher, what a thing that they have to choose like all the taxis or so that irritated some students, I think. Okay, so just quickly then the Google Sheet. So while they're doing the form, you've got this thing that populates automatically as they submit. There's a timestamp, there's an email address, there's what they entered. And if they uploaded something, there's a location on Google Drive. So that's in the sheet, and then there's my picture that I took all the questions in the exam, and I just watched that. Now, where are they struggling? Where are they submitting quickly? So it's lots of little browser windows that I just stacked together on one machine while I was doing other work. Okay, so that was Google Forms. Let's quickly move on to Excel. Obviously, that Google Sheet I then can download and first test myself. Did I fill in the form? It makes a sample Google Sheet, which I take down to Excel, and I put in automatic marking. So I can know when I add all the responses, I can just run through it. So it looks like this. So there's a Google Sheet part, and then I just code some extra if statements there to mark automatically, and then I send them that part as a PDF as feedback, so they know what the template was and what they got, so they can go and figure out where they went wrong. And for uploaded answers, it's the same, except that I've got these links all those blue things to where the specific students' uploads are. So you can see who uploaded, how many pages, who didn't upload. So it's a good feedback also. This was a mixed question with multiple choice and uploads. I can track the statistics of each question, individual questions separately easily as well. Okay, so I just give them that part, but I've got the whole thing for perusals. Okay, so finally, Acrobat, Adobe, where does that come in? So I think Warren also mentioned about fillable PDF forms to help Werner. This we had already in our department used our final year projects and designs were marked with fillable PDFs, so I knew they existed, but I didn't know how they were created. And yeah, I got a bit tired of how are we going to mark all these uploaded scripts. So you go to Google Drive, you see your students think, where do you write this? How do you make like a rubric, and how's it going to work? Because normally we did this all by hand, obviously. So I decided to go and find out about forms, and you can't do it in the sort of cheap Acrobat reader. You need a pro version, which we have on campus or as staff. So there's a tools button at the top, and then there's a prepare form. Now that form is best I found it's best if you make a template in Word and you just pull it into Acrobat. So it will create a form based on your template, and that template you can reuse again for different tests. So I haven't programmed that, but again, use one to start for the next. So I copy parts of the actual PDF of the paper into there, so this also becomes a memorandum for the students. So I believe that students should have the whole PDF of the exam. I don't believe they should just have their little window and you're doing this now and then you're doing this, because they need to be able to synthesize the whole exam paper and decide what's more difficult and what order I'm going to do it in. So I distributed the exam as a password-protected file a few days before, so they can download whenever there wasn't load shedding or when they had power or whatever. And then I just released the password at the start of the exam, and then they can read it first and obviously take their time to decide what they want to do. But back to the Word. This is a Word document, so at the top I've got the whole question they would see, and then at the bottom I've got there's an identifier for the student that they sign, who grades it, and then I've got this section where like all the steps and all the marks. So this is a template, a raw template with tables and stuff in Word, and there's also our EXA graduate attributes at the bottom that needs to be checked for this module. So that thing I just pull into Acrobat. So when you start a form, it says you can start from document. It pops up this thing. It looks a bit more dirty because all the table entries it wants is things you're going to fill in a value, so you have to delete some fields, but then you end up with the fields you want. And they include the student number, the signing and the grading, which then gets filled in by the teaching assistants or the grader, and then it automatically totals it, including the tick marks. Okay, so this then becomes a form that will get saved for each student. Now, inside those forms, I have to show some programming, otherwise Werner won't like this. So all those fields you rename to be question 1, 2A, whatever. And then you just type in some code, like the total is 1 + 2 + 3 + 4 is just a simple code. That's about what mechanical engineers can do. And then you go to Google how to add tick boxes to total up all the tick boxes. You also go to Google how to enter some JavaScript into your form. This was to slice the student number from the file name and put it into a field. Okay, so because I got tired, save as, go and type in new student number. I did that the first semester. And then how do I get all these PDF forms with the student number in them? So I did that manually, and then then Unix came in. So I had a class list of all the CSV file with a class list, and then figured out from, again, with the internet how to run a little script that will just take that PDF and just patch in all the student numbers on the end and bring it back to Windows and then go on. Okay, we're nearly done. So once you have then filled in all these rubrics for each student, you can then just dump them into an Excel file. Okay, so there's the wording of it. This is more for the recording. But basically you go to the More box there and then you go to Merge Data into Spreadsheet. You choose all the files and you end up with a spreadsheet which has all those columns that you had fields for. And obviously it already has the totals. They're not numerical totals. They're just, I mean, they're not a sum of all the columns. It's just that field that was in the form. But again, this is something I can release to the students and post-process further with the other questions. So that's automatic processing of all the data. It was reading on 500 scripts into a Excel spreadsheet took 4 hours to read in the individual marks of each student, just manually typing in from the stack of papers, so many high. So that was milliseconds, as Tanya said. Okay, finally, the lessons learned. My perusals 6-7 years ago, the line stood all the way to the cafeteria of students querying their marks. Then we started dividing them up into alphabetic groups, but it always took at least 4 hours to do the perusal session. And mostly it was people coming to look, not just to look for marks, but to study for the supplementary. So all that is gone. I think I had 10 or so queries. The marking is so transparent, there's nothing they can argue about how the marks were obtained because every sub-question was given. A few errors were made in the processing, obviously. Significant time was saved in the processing of the marks. The feedback time was obviously much faster. So quality internet access is still an issue. We always had people who struggled with connectivity. But there's a paper trail, so we could see what went wrong where. And then we also used these fillable PDF forms for practical reports. Again, the capturing was instantaneous. And then I know ClickUp or Blackboard had some issues with their servers. I never experienced a problem with Google servers being down during the uploads times. And the external examiners couldn't go into the same system and look at the Google Drives. Okay. Sorry, I took my full 20 minutes or 18. Cheers. There's one more. Sorry, I can let the contact off.
Ja, kan alles vullen. Okay. Thank you very much. Let me just stop this now because that is the time's up. Okay. Well, it seems like you're doing quite a bit of process engineering here to get all these forms connected and so on. Now it's very impressive. I must say I didn't realize it's so powerful. So no, thank you very much. And I think you will have to give out your contact afterwards because there's a. Can you quickly show that? Just thank you. Any questions before lunch? Yes.
Can we just show that slide on?
Okay, what number?
Just follow one.
That one?
Yeah, thanks.
Quick one so you can also paraphrase. How do you handle those tutor sites which guarantees between or after 30 minutes they will give you a worked up memo of your paper if you release the whole paper up front?
Sorry, say again. How do I guarantee? Yes.
To prevent cheating, how do you handle the tutor size, which guarantees an answer to your problem within 30 minutes?
Tutor size? Sorry? I don't get...
Can I?
Yeah.
Okay. So the question is about tutor sites like Check, right? Exactly that one we had trouble with. So there are some tutor sites where you can actually, in exam, submit your question paper and then they quickly work it out for you and then you can submit it. So the question is, how do you manage that? Do you have a plan?
The paper is in Afrikaans, and so that... No, just kidding, just kidding. Because it's Indian sites mostly you're talking about, right? Not just Indian. Okay, no. I mean, yeah, I think we have to trust that students don't do that. I know they do that, or some of them do.
I said it's a quick question, but I just want to add. I've seen one of my previous year students answer current year student on one of those sites this year. So it doesn't matter if it's Afrikaans.
I'm a bit of the opinion if students are innovative enough to go to all this trouble to figure out, then they'll probably make good engineers. So.
Thank you very much for that. And this concludes the session then. And so I suppose lunch is ready. Thank you very much.
Hey, good afternoon, ladies and gentlemen. Welcome back after lunch. And thank you, Prof. Alta, for a lovely lunch. So we continue our program, and we're talking about teaching with technology. And the first speaker is Inga Pieterse, and she will talk to us about a guided focus, a quantities measuring perspective. Inga.
Okay, wait, just guide me through here.
So you just use the arrow keys. Okay. Left and right.
But is it displaying?
Yeah.
Okay. Good afternoon, everybody. I'm a lone voice from the other side of the campus. And even further to the other side of the campus, we're on the other side of the road. So I decided to put a picture of our front door there. If you ever want to wander to the other side of the campus to come and find us, we're in the concrete building on the South Campus, and that's a picture of our front door. And I think it's only Alistair, if Alistair's still here, that actually knows where that is. But okay, be that as it may. So I'm going to talk to you about, and it's very focused on the model that I actually present, but I have stepped slightly back to it because I don't think that any of you get exposed to our environment that often. So I need to tell you what quantities am I talking about and what is the measuring perspective. So I thought to just tell you what the stream of quantities is. Quantities is our main module in the Department of Construction Economics. So we have the three streams of students, which is the quantity surveying, the construction management, and the real estate students. And the very first module, the HVH 101, which all three streams take there, you can see that is the module that I would actually be talking to today. That is the one that I present. And then you can see that the quantity stream, and I belong to the first stream, I'm a quantity surveyor. So we take quantities from our first year and it builds all the way down to the honours level. Now, Professor Wolf talked about scaffolding. I don't know if this is scaffolding or whether this is simply layering, but the next few pictures actually depict the outcome of every one of those modules as they move through the years. So you can see here on the first year, the outcome is that students must be able to measure simple building elements, which is like a garden wall on the left-hand side there. But the outcome of the curriculum is to measure the simple elements as well as a building up to roof level, and then starting right from the excavations all the way up. Then the second year outcome is to be able to measure an entire simple building. And there's no room in our curriculum for repeating any one of the trades as we go along. So in the third year, the outcome is to be able to measure a high-rise building or any complicated structure as you see in front of you there. So it's a lot of technical information that gets pumped into the students in a very short period of time. So then if I just can concentrate on the first module. So this is then the introduction into the quantification. So they've got to be able to read building drawings and construction drawings. They've got to be able to measure them according to a standardized method of measuring building work. And I will unpack these concepts a little bit later. And the purpose is to create a price determination document. Now, to lay people refer to those as tender documents. So by the time that the tender document is priced, it is the budget for any building project. And it becomes the basis of the cost control throughout the construction. So if students can't read drawings, can't apply the measurement rules, you have a terrible document with a shoddy budget and a nightmarish cost control as you go along. So you can understand that to get these concepts instilled in the first year is really quite a challenge. This module is or was classified, I think after last year I escaped that, but it was classified as a high impact module. And with this intervention, I think we have got a grip on that and we've moved out of that category. So my challenge as the first year lecturer is then to instill the correct writing methodology. And in a moment I will explain the methodology, because we don't carry our laptops and things onto a building site. You're not going to do that. So you're working in a team, You need to be able to communicate what you are doing with a team of people on a construction site, or even in a measuring team in a quantity surveying office. The second thing is then, our whole methodology is built around, and this might sound very archaic to all the engineers in the room. We use 2D drawings for a 3D application. Yes, there are fantastic things like the Revit and the AutoCAD and the bird's eye views and the 3Ds and everything else happening. But our students' reality is they must create what is around us. So if they cannot have the insight of taking a 2D and creating a 3D out of it, they've lost the plot. So our whole premise is that for the measuring stream of modules, we still stick to the 2D so that they can develop the skill of getting the third dimension out. And then the third thing, of course, is getting them to learn the rules and to actually apply the rules properly. So when I talk about a writing methodology, now Professor Wolf referred to numbers in her presentation and the context of numbers and so on. So if you pick up any construction drawing, the dimensions on the drawing are actually notated in millimeters. But to be able to measure, you've got to convert those millimeters into meters to measure, because you can imagine if you're going to the third category there, cubic meters. If you want to do cubic millimeters, you're going to have 6-digit numbers for everything that you're trying to create. So it's not going to work. So those numbers then need to be converted. And as simple as this sounds, you cannot believe how difficult it is for me to get the first-year students to stick to these rules. The youngsters of today don't want to be in little boxes, but unfortunately this module is very much about the box. If you don't do it right, it culminates in financial damage either to the contractor or to the client. So if I say something is measurable in linear meters, let's say, argument's sake, the skirting here of this building, I've got to do that in linear meters, but for the contractor to be able to price it, it needs 2 dimensions. So I need to say this skirting is 20 millimeters wide and 100 millimeters high. Otherwise, it can't be priced. That's the first thing. The second thing then, square meters, so the 3-dimensional world. Either you have your dimensions in your dimension column or in your description. So it's a twin. You can't loosen these. So the challenge is also the linguistic ability of the students as well as the numerical ability of the students then. Okay, so the measurement rules that I keep on referring to, the book of rules that we work to is arranged in trades. So if I say trades to you, you think of plumbing, carpentry, things like it's exactly that. So there are 28 trades in this measurement book of ours, and as we go through the years and as the buildings become more complex, the different trades are rolled out. So just to give you an idea, on the first year, the 6 trades are covered. So in the first part of the curriculum, I'm covering the basics, like you've got the measurement rules, and this is the way that you deal with them, and this is the way you've got to generate your dimensions and all these kinds of things. So there are the 6 trades that we start off, because those trades enable a student to be able to measure the simple structures that I showed just now. So that's earthworks, concrete formwork, reinforcement, and I'm saying partially because on a simple building you would have strip footings and surface beds, so on, and it's not high-rise kind of concrete applications. So the more involved concrete work, masonry work, waterproofing lies with the high-rise buildings, and they come in the 3rd year again. And then the other 2 trades are then the plastering and the paintwork. And that would then allow them to measure a simple building. So for me to be able to illustrate to these students how we're going to measure, these tools need at one time to be on the desk. So in the middle you can see I've depicted a drawing over there. So that shows a plan, but the drawings aren't just a flat drawing. So I need plans, I need sections, I need elevations, and depending on what the design is, sometimes I need some schedules that shows windows and doors and all kinds of different things. It all depends on how the design information can be communicated. So that's one set, so they've got a drawing. Then on the left-hand side, I've depicted the book. That is the actual, you can see the cover. I don't know if it's too small, if you could read perhaps in the corner. That is a book published by the Association of South African Quantity Surveyors, and every quantity surveyor has a rule book on his bedside table. We're never far from our rule books. This is the practical thing. Every quantity surveyor in this country has one of those green books, and they carry them. Then the right-hand side are the purple books. Those are the specifications. So if I want to measure a wall, I need to say what the bricks are, what the mix is, but I don't need to say what the compaction strength of the bricks is. I just need to say it is a NFX bricks or an NFE brick or whatever, and the specification document will give the detail as to what that is. But I still need to pack enough information so that it is a priceable item. So I say the bricks, I say the mortar mix, and yeah, that's enough to do a brickwork. So on the bottom line over there, I have a word icon, because together with all this information, we have explanatory notes going forward. Then I have a PowerPoint presentation, because I've got to explain step by step to these students how this is done. And in the Excel, I have a worked example. So with every drawing, there is a worked example of how the rules have actually been applied and the dimensions thereof. So at the first year level, it is very important to show a student, look, when you're measuring, argument's sake, brickwork, you are measuring literally from this line to that line. And it's very much a chalk and talk kind of exercise that needs to be simulated, because they simply don't know. They've never read drawings. They've never been introduced to the building technology before varsity time, and obviously definitely never the measurement rules. So all of this is now either made available beforehand, but in a lecture, and I use Blackboard obviously for my lectures now, my first situation was, I've got all this information and I'm jumping from the one to the other because I need to illustrate to the students the interconnectivity of how all these sources are working and where you need to look and what you need to do. But okay, then the measuring technique itself, I said just now that this is a twin. So there needs to be a description. The description needs to be accurately enough to be able to price it. I won't go into too much of that detail. The second part of the twin is the accuracy and the correctness of the dimensions. So if you have a description but you don't have any numbers, it doesn't mean anything because it's not priceable. Or if you have a hole, because you can imagine if you're building something like Mainland Main or something like that, if you're measuring the floor area or the ceilings or the whatever, the dimensions carry on forever. So if you have a string of dimensions that aren't referenced properly or written in the correct dimensions for the correct measurable unit, it's chaos. This creates an audit trail for going forward to pay contractors every single month, to do your cost control to your client, and to close out in terms of what the final value of the building is. So what I'm saying is, any one of these trims, the one without the other, is meaningless. So that is quite a bit of a challenge to get that right. So my first attempt on the Blackboard was disastrous, because you're coming from a face-to-face where when you're sitting in a practical session, the students have all these tools around them on the desk, and they consult that source and that source and that source, and it's happening. But while I was trying to simulate this, obviously it was a question of, and I think all of you can share with me when I say you're jumping from one application to the other and then the distortion happens because the Excel doesn't look like the Word and it doesn't look like the PowerPoint. And you get distracted so much because you are trying to fiddle with all these things to get them right, that to me it was immensely irritating. I don't even know what the students thought about it. But sitting a little bit after that lesson, I thought, obviously a plan needs to be made, because otherwise I'm going to go crazy or the students are going to murder me, but this is not going to work for a whole year. So the plan was actually very simple. I just said, I can't use all these sources at the same time, so these sources must be parked. And I chose the simple common denominator of a PowerPoint, and I took the two content areas and all these drawings that we use. I cut and paste the specific measurable item into the left-hand side, into the one content area, and I cut and paste out of the handouts that the students would have in any case, the specific measurable item with its description and its dimensions next to it. So as an aftermath, after I saw my results, and I'll tell you now what that was, I realized that for the first year, since I've been teaching this module, the students were really focused, because even if they have a big drawing like that, if I'm standing in front of the class, you don't know if that student is really understanding exactly where you are busy. But now, because I had a cutout, the student was looking at exactly what I was saying. They had, because obviously in preparation for the lectures, the drawings and the handouts and everything else was made available beforehand, and they had to prepare for every lecture. So that was the situation, and just to illustrate to you what that was, is here is and it's just a simple little example out of a first year example. So there where the two arrows are, you can see that the measurement item on the right-hand side actually applies right there. So basically, I could then use the tool in the blackboard. Yeah, I could use the writing tool in the blackboard to further illustrate this. So if you go and look at the so I would make the PowerPoint available beforehand, and then the lecture itself would then be a voiced PowerPoint using the illustration tools as to say, literally from that point to that point, that is what the 1.8 is, argument's sake, or wherever that dimension is coming from. And then on the right-hand side, where the measurement rules would require, you know, what you put in your density needs to be in your description, or whatever the rule is that you are busy with. The message that I have actually is that this was so focused that the students didn't have a choice but to see exactly where I was busy, and that made all the difference. The second thing was that the student feedback that I got is the over and over. The students said to me, we can watch this over and over until we understand. And I think that is the biggest takeaway from this, because face-to-face, if you don't come to class, you miss the lecture, you have pockets of information in this building up. You know, I would, to this day, have third-year or honours students walk past me and say, you know, ma'am, the day you did that and that, I wasn't in the class. I still don't know how to calculate that or whatever. But that makes pocket of missing information in the bigger total of our measuring scheme. Okay, so the long and the short of this is that I said just now that quantity is or was a high impact module, and this focused view resulted in an 11% increase in my throughput. Sorry, people, I'm asthmatic and I've been suffering a few days to breathe properly. So if Professor van der Merwe looks at her results, she's going to see the 22%, but there were two other interventions that happened in our department at the same time. So the 11% was really attributable to this changed method of approaching how my classes happened. And that's me.
Thank you. Are there any questions for you?
Nothing.
Okay. Thank you. Our next speaker is Talia de Silva-Burg, and she's going to tell us about creating student engagement in an online tutorial class for large student numbers. I'm looking forward to that large student numbers.
Thank you. It's so nice to be here in person, and thank you to Prof. Alta for really pushing for this to be something where we can all meet and see each other and see where we're struggling with similar things in very different departments and trying various alternatives. So in today's presentation, I'm going to give you just a little bit of a story of things that we've tried in our tutorial classes specifically, and what worked and what didn't work as well as we'd hoped. So a bit of context, the module that I'm talking about is a service module for all first-year engineers. So I'm from the Department of Civil Engineering, and the subject area is statics. So this is an applied mathematics and concepts course. And as Prof. Wolf was saying, we sit at that transition from the engineering and mathematical sciences, from the natural and mathematical sciences to the engineering sciences, where there's a big paradigm shift, cognitive jump in getting things together. And we really have found that students struggle. So our cohorts are quite reasonably large, 1,500 students. There are modules in the university that are bigger, but in our department, this is the biggest one that we have. And there's a team of us, there's 4 of us that give our all for this module. And it is classified as one of the EBIT HIMSS high impact modules, which means we get a little bit of special attention and lots of people wanting to know how things are going. So how our module looks is we have 2 main contact times. We have the lectures and tutorials. So there's 4 lectures a week and a double period of tutorials, and those are split across 3 groups. So the lectures are generally about 500 per group, and the tutorials would be about, they usually split about 700, 700, 100. There's a small group on the one day. In preparation for these, we get the students to do some little quizzes online. So there's lecture assignments and tutorial preparations, and this they do in their own time. I mean, our hope and expectation is that they do this before the lectures, but we'll see a bit later that this doesn't happen quite as we expect. And then what used to happen when these used to run in person is that at the end of the tutorial session, there would be a short little test. And this was to kind of aid that, so these yellow blocks are the continuous evaluation marks, to kind of encourage participation and give students just little bits of marks where they can hopefully build towards their semester mark, where it's not just these high stakes test environment assessments. So the lectures are generally quite passive, and the tutorials, hopefully, if they're done right, would be a bit more of an active session. So when things were run in person, the tutorials would be over 3 days in multiple separate venues, and we have a standard worksheet. Everyone gets the same worksheet, and you work on the problems, and there is a tutor who's there to help you. If you get stuck, you put up your hand, and they give you some instruction. I must also add a qualification that I only started lecturing in July 2020, so it was mid-pandemic. So this brave new world is basically all I know. So this is now from my colleagues from when they taught it, and obviously when I was a student and did this coming through. But we really believe in our module that tutorials are the coalface of the module. We want this to be the place where students are sitting and engaging with the material and are struggling with it themselves, and not another opportunity for them to just sit and listen to us describe the memo. So in 2020, when everything went online, this was kind of our survival mode. And our lectures became pre-recorded lectures with a discussion class about every 3 to 4 weeks, usually just to discuss semester test memos and any high-level questions. And the tutorials became led on Blackboard Collaborate, and we had our tutor team lead those sessions. We had the same continuous evaluations for that, but instead of the tutorial test, what we then had is we had a duplicate of the tutorial worksheet that the students were given with their own unique values that they had to complete and submit. So this ended up meaning that the students' own time started being impacted in, again, that it wasn't just something that was done within the tutorial contact time, it required a bit of additional time for them to complete that. So how it looks, you don't have to read the numbers, but they would have gotten a standard worksheet that would have been worked through in the tutorial, and then they would have logged in online on the right and got in their own unique variables. And I'm just going to take a bit of a sidetrack here and say we use the numbers system for the parameterization and we found we also use the AMS for the hand calculations and rubric. But we found the numbers to be incredibly powerful in terms of you get that visual representation of the problem with all its variables. And when the students get feedback, they can see on there what the answer should have been right next to where the answer goes. And so we really like that very visual interface. And it doesn't require loads and loads of programming, which is a huge plus. So aside numbers, very interactive and very pro numbers, it does have some challenges, but yeah. So this tutorial worksheet was exactly the same questions as the SAND worksheet. Students had 24 hours to complete the worksheet once it was opened, and it was available for the full week until the Friday. And they could see, so this is an answer to the previous question, they could see when they entered their answer in if it was incorrect or correct. So they couldn't see what the answer is, but they could see that it was incorrect, so they could resubmit until it was correct. So this was kind of like the guiding rails when you play bowling alley, you know, just no, 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 yes, okay. So attendance, we had 12 weeks, and this is over the 11 weeks that were used in the assessment. We had steadily decreasing attendance, but still quite good. So our cohort is about 1,500 at the beginning, and then steadily drops off after each semester test. And the average score was pretty good, you know, between 70 and 80%. So students were doing well. And just an aside, so this is the participations, and they had until Friday at midnight. And you can see as we go through the semester, that curve becomes more and more concave, and we are coming more and more until Friday. So it was just interesting to see and maybe understand a bit more why. You know, in the first week we were engaged. I'm going to start early with my tutorial preparation. Second week, not so much. Third week, things are getting really hectic. And this was, we had hoped that they would do the tutorial worksheet in time for their tutorial session so that they could get input from the tutors. And we'd set cut-off limits at 2 o'clock on a Friday that we will not be able to assist you after that. But still, what's that, more than half the class is leaving it until Friday afternoon. Anyway, just an aside, students are students. And so our tutorial sessions, we had 3, and we had led by about 2 tutors, and these were basically just large group plenary sessions. So there should have been, if everybody came, about 700 students on a Tuesday and a Wednesday, and about 100 on Thursday. We didn't track attendance last year, but anecdotally, at the beginning of the semester, about 100 per group, and then as Caitlin was mentioning, there's severe attrition, and at the end of the semester, maybe about 20 students per group. So some of the challenges that we faced in this module is that our tutorial time became quite passive. It was the students sitting there and the tutors just working through the memo without the students actually engaging with the material themselves, and this is not what we wanted. The session was led by the tutors, and because we were also not doing any lectures, there was actually very little interaction between the lecturers and the students, other than once every 3 to 4 weeks, and all the emails, and obviously we have email addresses and stuff, but there wasn't this opportunity for this positive engagement where students could come and ask lecturers. It was then also a lot of additional work for the students to go and have to calculate that complete worksheet with their own values. So they were adding to their own time, and then they were leaving it till the last minute. So as I said, we now end up with 2 passive times, which we wanted to prevent. So when we were planning for this year, the 3 things, if we focus on the tutorial sessions, this is where we really wanted to get the engagement, that we changed or that we wanted to focus on. And the first thing was the format. We played around with a different model in the summer school, so we have lots of opportunities to try different things. So we played around in the summer school of having more tutors and having smaller groups, and that the aim of that would that it would stimulate discussion. There's a lower threshold to participation. There's only 20 other people and asking a question. And hopefully people could work together. And the second thing was the way that the tutorials worked with the continuous evaluations. We wanted it to be a non-threatening environment, and that it's not about getting the answer right, but it's about understanding the process and asking the right questions so that you can solve the problems if you had to do it on your own. So to this end, what we did away with was that worksheet that you had to do with all your own values, and everybody does the same worksheet. And at no point are you needing to enter those values in. So if you're there at the tutorial, you actually should just be trying to see if you can figure out how to do these problems and not pressured because this now counts as an assessment. And we thought one way to do this would be to replace it with a more qualitative tutorial feedback document. So at the end of the session, they fill in a Google form with just some qualitative questions, and I'll go through some examples. And then it's a participation mark. It's a 1 if you've completed it, or a 0 if you didn't. Quite idealistic. We'll see how that turned out. And then the third thing was that we wanted the lecturers to be much more present in the tutorial sessions because this was the only real contact time. So the tutorial sessions were overseen by a lecturer, so there's 4 of us. And so for the 3 sessions, 1 person took responsibility for a session. And we tried to make sure that, for example, I took Thursday sessions, and I took Thursday sessions throughout the whole semester, with the exclusion of today, obviously. And the aim for that was to generate maybe a little bit of rapport between the students and a certain lecturer, instead of them needing to swap between, if I did all of week 1 and somebody else did all of week 2, then they needing to swap between all the different lecturers' styles of running the tutorials. So the aim, again, we have the lectures. We also changed the lecture model slightly, that we had a weekly discussion class instead of just every 3 to 4 weeks, where they could ask questions on a weekly basis. And then tutorials were led by a lecturer with breakout sessions facilitated by the tutor team. We had the same continuous evaluations, but now we try to bring back that tutorial assessment back into the tutorial contact time. So hopefully this was the plan, that would then be passive and the tutorials would again be something a bit more active. So if we look at the tutorial in a bit more detail, we had 2 components. So we had a main room, which was a plenary session, which was set up in BBC, that everybody in the class can access. And then we had small group rooms that students met in pre-allocated small groups to discuss and work through the tutorial worksheet. And for those pre-allocated groups, we created ClickUp groups that they could sign up to for a maximum of 25 students per group. And the aim of that was that if you know people from your first semester, maybe you've been in contact with someone, you could have some friends that you could sign up with, and you could all be in the same group. Again, this worked that aspect of it worked well, where people had an existing community and were able to do that. But for students who didn't, it was quite challenging. They may have ended up in a group and never actually built that community. So in the tutorial session, it's 2 hours. So we had, you'd start all together, everybody's all in the main room, and get a generic overview of the tutorial. And then everybody would go open up another Collaborate tab and enter your breakout room. And we had tutors responsible for about 2 to 3 groups. And the tutor would then hop between each group and answer questions, stimulate discussions, provide any memos or anything. But what this prevented from happening is the tutor just sitting there and working through the memo. They weren't able to do that. They really had to rely on the students engaging and interacting. And then at the end, the students all came back for the last 20 minutes, and depending on who was running it, you would just get a high-level overview of what you should have achieved in the tutorial session, maybe the answers, so that if you wanted to go back, again, you could look, and the blue bits were recorded. So if someone wasn't able to attend the tutorial session, they could still have access to some of it, because that is a disadvantage, is that to actively participate, students would need to get onto Blackboard, collaborate, and have that data. So the reason we chose ClickUp groups instead of using the breakout room functionality within Collaborate, primarily for autonomy and continuity, so students could choose who they wanted to be in a group with, and the continuity so that students could develop a working relationship with a group of other students and know what to expect. Additionally, this allowed students the freedom to move in between the rooms as they wanted to. If they wanted to be in the main room and just sit and work by themselves and wait until the lecturer came back, they could do that. Or if they wanted to be in their small group, they could do that. And in the small groups, they then had full functionality. They could share their screens and videos and everything. And then the tutors would have all the Collaborate sessions open and they can monitor the chat. One of the problems with the breakout rooms that we found in Blackboard is that when you move from one to another, if you're a moderator, you have the functionality to do that, there's no break, you can't see the chat, what's happened. So you lose that ability to see what's been happening. Whereas if you have a Collaborate tab open and you've just got it muted, you can like really just pop back in and just see what have they been chatting about and give some guidance and feedback. So those were the main reasons. So what worked and what didn't work? So the small groups worked well where there were high numbers of students attending the group and they were engaging and students had prepared partially at least. And on the contrary, low attendance made it difficult and not productive for either of the students and quite frustrating for the tutors too, to sit, does anyone have any questions? And just wait, or like, where did you start? And even though groups had 25 people signed up, only about 5 to 10 on the high side would attend. And we tried to mitigate this by clearing the groups and sending messages saying, okay, you can re-sign up for a group now. But students still signed up. I don't know if they were ambitious and thought they would attend, or if they thought they would like get some kind of participation marks by like showing they enrolled in a group. But anyway, whatever the reasons are, they still enrolled and didn't show up. And so what worked is that it was definitely much better than our previous model. In 2020, it was the students were able to work through a worksheet and get directed inputs where necessary. Okay, so moving to the tutorial feedback. So the reason we went from a quiz to this feedback is we wanted something qualitative and low stakes to encourage participation, a proxy for attendance, and to gain feedback and input from the students. So it was Google Form. We also, like Professor Craig, have learned a lot about Google Forms. And the answers were validated by tutors. And that also provides the tutors an opportunity to see what their students are learning and thinking. And students get 1 mark for valid completion, which contributes to the continuous evaluation component. So some question examples are just like, how many of the homework problems did you complete? What did you find helpful? Have you completed the tutorial preparation? Which questions did you find challenging? How would you rate your own understanding? And whilst this was useful to see, it generated a lot of feedback that you actually cannot very effectively process and react on. And it wasn't an opportunity for students to actually learn or engage. So we started moving on to more basic conceptual questions that allowed us then in the next TUT to give a snapshot of understanding. So you have a multiple choice, and I can quickly say that here 51% of the students got it correct. You don't need to be able to read that. And that allowed us to feed back. However, it was apparent that there were large numbers of students, obviously, just logging in right at the end just to get the feedback form, which we felt defeated the purpose. And also the tutors got quite frustrated in this when they had to do the validation, and they would say, I got a phone call from one saying, this person has said that he attended my small group, but I know he was there because I was looking and he wasn't there. I said, well, I mean, he's completed the feedback, so we're just going to go. Okay, I'm nearly done. So we moved on to a short, really short quiz, and this was the model that we actually found was the one that we were most comfortable with in the end, that the students were actually engaging with material to earn marks, and it wasn't taking a lot of additional time. So just out of interest, the blue line is the attendance on the left in terms of numbers, on the right in terms of percentage of our registered class. and the yellow line is how many students actually completed that feedback at the end. So it's consistently about 50% more just kind of logging in. But participation quite low. I've got the discussion classes there also as a guideline. Okay, last thing, I promise. The one thing that we did was we also took those additional tutorial worksheets, and because we already had them, we decided we're going to make them available to the students that they can use as practice. They were already programmed, it was no effort for us. The downside of this is that once you've addressed a concept, then doing the maths is easy. So if you're doing the same problem again, you're not actually learning a new concept or a new situation. So it helped them with practicing the maths. And we can see here, this is just as we go through the term. I think you can guess when our semester tests were, 13th of September and 30th of October. But this was actually very encouraging to me that students were engaging with this. And this actually gives us a model to look forward and maybe creating these quiz banks, maybe separate from the worksheets and just more thematically think if I want to practice questions from this theme going on. Okay, so it was helpful and was lovely to hear back from the students, but ideally we'd hope to transition to having things in person. Until such point, the small group model worked well, and active student participation makes the process beneficial for all involved. But until then, we will be happy with those that are there, and hopefully that it is good for them. Thank you very much.
Any questions for Talia? We think we can handle one question if there's... Okay, thanks a lot, Talia. Okay, our next speaker is Warren du Plessis, and he's going to tell us about encoding video lectures for low bandwidth connections.
Eventually. Just three. Three dots. It was there a moment ago. It was, yeah. Computers make very fast, very accurate mistakes.
Doesn't make sense. It was here.
We tested this beforehand, I promise. I don't know what's going on here. Oh well. That's weird.
Very weird.
Yeah, because there was just the... Try F11. Normal fails if you... Well, I think this is good. We're going to get single page. Just go... Page view. Single page.
Single page, yeah. It's not working. The three dots.
Three dots vanished.
Yeah. Is this still online? Check three dots.
At least I'm not the person typing. Yay! Okay. All right. Yay! My presentation has appeared. All right. All very exciting. All right. Hi, everybody. Well, welcome to my presentation. Hopefully it will be of some interest to somebody. As you've seen, I'm a bit of a computer nerd, so I tend to spend a lot of time thinking about things like, how the heck do I get my videos down to a size that the students can actually use them, and then set up a whole presentation about it. So yeah. So firstly, why recorded lectures? And this is a photo on the right here of my desk when I had it nicely set up for one day. So you've got my computer and the microphone and my tablet I'm writing on. And my cat, who died about a month ago, which is a really sad photo for me. But it's the only photo I've got of my setup. And he used to sit there. It was actually in 1 year, the students would ask me every session, so is your cat there? How is he? You know, what is happening? It was quite amusing. Anyway, so why recorded lectures? Well, during lockdown, we've got no alternative. We need to have something like a lecture. We desperately need it because The textbook is one thing, and you need to give another perspective, which is why lectures just reading from the textbook doesn't work. However, doing something different gives the students a different perspective and often helps people to understand things that they wouldn't otherwise understand. So it complements the written material. And video lectures are a lot like normal lectures. They're also a lot not like normal lectures. I think if there's one thing that this lockdown has proved, for me anyway, beyond any shadow of a doubt, is the days of the brick and mortar university are not numbered. It is so important. The ability to stand in front of a class and just see the whole class go, you really, when you're trying to explain something and you just see this glassy expression. I can remember one event, or one lecture where I was standing there, and the students, the whole class, just got this glassy expression, sort of, okay, I will explain that again in a different way. And you lose that with video lectures. So I'm very much, after this lockdown period, a fan of we are going back to campus as soon as we can. We have to, because it is just different. But even when lectures are possible, recording lectures adds a lot of value. I just quickly checked now, I've been recording lectures since September 2018. So I was doing this long before we had to. Just purely because the students had asked me to, and the feedback I'd got from the students was so incredibly positive. So we already had someone speak about the effect of missed lectures. That's a big deal. Sometimes students just can't get to a lecture. It also allows students a convenience. They can watch the lectures wherever and whenever they want to. So if you've got a night owl that is working on USA time, they can watch the lectures at 2 o'clock in the morning. That's fine, it's not a problem. They can also stop and work through a particular portion multiple times. Whereas if you sit in a lecture which isn't recorded, if you've missed something, you've missed it. So recording lectures, even when we get back to campus, I will continue doing it because I have seen the value in terms of the feedback the students have given me. So recording lectures, that's how I normally lecture. So I have my stylus, a tablet, and I record it on there. I use some software on the tablet. Most people tend to use things like Open Broadcaster Studio or the Blackboard Collaborate tools, and I'm going to give some examples of those. The problem is the files that pop out of an hour-long lecture weigh in at between 100 and 300 megabytes. That is enormous. Now, even if bandwidth is not an issue, if you've got a 2013 computer like I have, you keep running out of hard drive space just due to the size of the lectures, all right? And even if we give the students free internet access, which we have on the various platforms, it takes a heck of a long time to download a 300 megabyte file if you've got dial-up connectivity speed. So just posting a video lecture, just recording a lecture in Blackboard Learn does not mean it is accessible to the students, and this is a really big deal. The first thing to do is, and it's actually Alistair who suggested this to me years ago, is to post it on YouTube. YouTube has different quality levels, from not that great, but actually surprisingly good, to whatever you uploaded it as, and a couple in between. But even then, you end up with the smallest YouTube file is still shooting for a pretty high quality. It's still a pretty big file to download if you've got expensive data or a very slow connection. So what I've done then is spent way too much of my time figuring out how to effectively compress the video files down to next to nothing. And this is like a 2-year process I've been going through, so this is, you're lucky you're just getting the summary. So this one I'm just going to go through quickly. These are the video codecs. So these are the things that encode the video for you. H.264 AVC is a very widely used thing. It's part of the MPEG standard, so is H.265. H.265 is not well supported. It's much better in terms of the size of the videos, but it's really not widely supported. So I started off using H.264 because it's just widely supported. Then, earlier this year, I realized there are open codecs. These are things that are open and royalty-free. You can use them with no license. So even if the MPEG standards body decides nobody's allowed to use H.264 at some point, VP9 and the AOM or the AV1 video formats will remain available. Are they widely used? Yeah, they're used on YouTube, among other things. They're also part of the HTML5 standard. What that means in English is the internet standard. So everything supports them. Your web browser probably supports those bottom two video formats. Not just your video player, your web browser probably supports them. And they are much more efficient in terms of reducing file sizes than H.264. But the thing that made the really big difference was, we all know MP3, it's the good old music encoding thing, Napster and company come to mind. But basically it's MP3 because it's MPEG audio layer 3. All right, it's ancient. It's really old. Audio compression technology has advanced in leaps and bounds since then. The replacement for MPEG or for MP3 is AAC, which is widely supported but not that widely used as far as I can see. So basically you can run it on anything. And then far more recently, and also sort of part of this open standards process, is the Opus codec. Now the big difference that makes a massive difference in this case is the Opus codec is not built purely for high quality audio. The others are built for high quality audio. So if you want to include low quality just speech, they'll do it, but they're not going to enjoy it. All right. Opus is designed to go from everything from just encoding the speech all the way up to high quality audio. And that's great, because when it's a lecture, it's just speech. I don't want all the rubbish that comes along with high speed audio. I just want the speech. And it's made a huge difference. So just 2 test cases. These are just 2 lectures I took. They were the first 2 lectures last semester. The first one was 40 minutes long. I recorded it using OBS. I used the full high definition resolution of my screen, and it came in at about 125 megabytes. That's actually not too bad. And on the right are just 2 screenshots from it. So it was just working through the study guide, working through the ClickUp page for the students. So it's mainly text. And the second one is the way I more normally lecture, and that's I draw with a tablet. And no, I don't know what's going on in those diagrams either, but they made sense at the time. So it's a totally different type of scenario. This one was about an hour and a half, and yes, my tutorials do normally tend to go up to an hour and a half, especially if they're questions. If they're still questions, I will continue answering them. It was recorded using Blackboard Learn, so this is indicative of what one gets from that. So these are 2 very different scenarios, recorded in very different ways, but if this is what I'm doing works for both of them, then we should have good results from there. Yeah. All right, so the compression parameters, I was aiming for less than 10 megabytes an hour. So we're speaking about 100 to 300 megabytes file. I want to get a file that's between 10 and 15 megabytes at the end and is still usable. That's the trick. The big difference, the huge difference that happened in the last year was discovering the audio codec. I can now have an audio bit rate of 10 kilobits a second. It's like nothing. Normal CD audio is 128 kilobits per second, so it's more than 10 times less than that. Normalization just says adjust the volume so it's not too quiet. The students complained that many of my recordings are a bit quiet, so I tried to do that. The video, 8 kilobits per second. Perspective on that, the default on most systems is on the order of 5 megabits per second. So we're talking of 1,000 times less. And one of the ways I did this was to reduce the resolution. Now, reducing the resolution does make things a lot more blocky, but it's amazing how well your eye can kind of interpolate, especially in a video. And a lot of the video players, when you resize them, they actually do make the video look better than it actually is. And so you get surprisingly good quality. Now, that's about as fuzzy as you get, but basically I haven't been lynched yet. All right. So here's some examples. At the top, H.264 from the first one, you can see you can barely read what's going on. H.264 with a higher data rate and a better resolution, you can now see what's going on, and the VP9, much the same. So these are actually now usable. This one, same sort of thing. And here, if you look, you can see the top one, you can't see what's been highlighted in blue at all. Whereas the bottom 2, you can start making it out. Now, we can argue which of the bottom 2 is better, but they end up being much the same. All right. On this one, you probably won't be able to see it, but there are lots of little dots and things on that top one. There are lots of artifacts that crop up. On the middle one, there are also artifacts, but you can't see them now. But if you zoom in, you can see them. And if you actually watch a video with it, you can see the little artifacts. And the bottom one is much cleaner. And given that I work in the bottom, sort of this handwriting type way most of the time, I prefer the VP9 codec. So the quality is good. This is a summary of what I achieved. So starting with a 125 megabyte file, I was able to get it down to on the order of 6 megabytes. All right, that's not bad going. Starting with a 240 megabyte file, I was able to get that down to around 14 megabytes, and that's an hour and a half lecture. Now you will notice I am studiously avoiding the last line. The last line is the AV1 codec, the super duper new ultra standard codec, and the reason is it took literally hours to encode the video. Yes, my computer is from 2013, so maybe it's not a good example, but I'm just not going to wait that long to encode a video to save someone half a megabyte. I'm sorry, maybe this makes me a bad person, but it doesn't seem to be worthwhile. The point is, relatively easily, with the right settings, we can get these things down to a very small size with acceptable quality. So if you're like me and you like doing command line stuff, that's what I did. All right, if you're a normal human being, there is a thing called Shutter Encoder, which works on every platform. Now, if this presentation is distributed afterwards, those things that are underlined are actually links. You can click on them. So I assume the presentations will be distributed afterwards. And what I've done in the interim is to make a video saying how you set the thing up and how you use it to do this. So basically, there are a bunch of settings you have to set on the right, or alternatively, you download the little file I set up. So there you go. So, and then there's some more settings. The video explains how to do all of this. Otherwise, just use the file I set up. It's just figuring out where to put it that's a problem. And what's nice about this thing, at the bottom left, it's got a little thing there that says work during inactivity. So if you're working on your computer madly, it'll say, whoa, okay, hang on, let's let the person work. And then we go out to have a cup of tea, not coffee, tea. Then your computer will carry on working. Sorry, I, for some reason, prefer tea. Anyway, your computer will carry on working when you're not working on it. And the speed with which these things encode means that you can basically set this up overnight, come back the next day, and the videos will be finished. You're normally talking, at worst, if it was an hour-and-a-half lecture, it'll take an hour-and-a-half to encode it. And then what I do is I upload these onto ClickUp, because now I'm not busy filling ClickUp with 10 gigabytes of files, which somebody would complain about. I'm filling it with 500 megabytes for an entire semester's lectures and tutorials and everything, maybe. It's nice, and I can keep those and make them available year after year. So, lecture recordings are the new normal, but even if we don't need lecture recordings, I have seen the benefits that they offer. The students consistently thank me for doing it. But video is the most bandwidth-intensive thing we as human beings have right now. It's ridiculous. So encoding, just doing simple things like using the Opus codec, the VP9 codec, both of which are supported by, as I say, your web browser can probably play them. Which is great. And then the options that I've set up, there's that MPEG, that FFmpeg command line if you want to go and set up a script like I've got. Otherwise, Shutter Encoder is built to be simple. It is simple, and it gives the same kind of results. So I really hope that my last couple of years of fighting with big video files will be useful to somebody. So thank you. Short, okay.
Video editing software, what do you recommend?
I don't edit my videos, so I don't have any idea what video editing software to use. I have used OpenShot sometimes, and I just need to crop things in and out, but I'm not sure it's that good. Shutter Encoder can do a lot of basic video editing. So basically, just using it to re-encode videos is like taking a Ferrari and using it to drive at 10 kilometers an hour for the rest of your life. It's a much more capable tool than that, so it can do a lot of those things, but I don't have a specific preference or suggestion on video encoding. I have used Handbrake. The reason why I did not use it here is it's not as it's not as cross-platform. One can do exactly the same things with Handbrake, but Shutter Encoder runs on everything. So the prof who a year ago asked me for something he could use on his Mac, he can use it. I can use it under Linux. And I'm assuming you're using Windows, you can use it under Windows, and it looks the same and it works the same, so I can set one video up, not 5. All right, thanks very much.
Thank you, Warren, for keeping it simple for non-technical people. Okay, our last presentation for the day is from Elisabeth Tui, Vygotsky in a time of COVID.
Yes. Does it work?
Yes, yeah. So you just click and then it works.
Is it live? And this is the slide that also works. Afternoon, colleagues. Thank you for staying and listening to me in this last session of the day and also the last presentation of the day. So I'm preaching to the choir, but I'm going to give you a bit of learning theory background. And I think many of you, we've seen that many of you are actually employing it in your reflective teaching practices. So let's start off with some background. Lev Vygotsky was a Russian-born psychologist who lived for only 38 years between 1896 and 1934. But he's generally recognized as being the father of the social constructivist learning theory. So this, according to this theory, it views all human development as a socially mediated process. So it states that we acquire all our cultural beliefs, our values, and most importantly, in our context, our problem-solving strategies through collaborative dialogues with more experienced members of our society. And I am now going to view, and I think we can view all of the presentations today through the lens of this social constructivist learning theory, one of the teaching strategies that I employed during the past few couple of semesters. And specifically, I'm going to focus on two of the most important aspects of this learning theory. So, oh no, the advanced is not working, let's just do that. Okay, so the first is that of social context. So constructivism, learning as a constructivist thing, all the constructivist learning theory says a learner must be actively responsible for constructing their own knowledge. And the social constructivist knowledge theory also supports that. The learner is still responsible for constructing their own knowledge. But it also recognizes the important role that a more experienced person can still play in this learning process. So thank goodness we all still have jobs. Yes, that's the first part. The second part is that of mediation, and we heard a lot about mediation and scaffolding today. Of course, mediation is that process in which the students are allowed to appropriate the cognitive tools in order to make knowledge construction possible by giving them a task or an activity that they can't do on their own. They need interaction with somebody more experienced who already completed that task in order to achieve success. And this more experienced person is what Vygotsky now called the more knowledgeable other. And a key aspect to how he viewed this process is through this zone of proximal development. And that's that critical space, according to Vygotsky, between what a student already knows and what he can do on its own, and an activity or a task that he can't master on its own, but he can do that with help. For instance, Warren's video suppressing stuff, I already saw him in Flexible Futures. I found that wasn't in my zone of proximal development, because I tried that for 2 hours. I'm very glad that you spent 2 years on it, but after his presentation, I was really, yes, this is worthwhile, I should try it, but it wasn't in my zone. Okay, so I'm glad you are providing the scaffolding that I'm going to need in that video that you promised. So this mediation process, of course, lots of us talked about scaffolding. Scaffolding, in the context that I used this, is that a form of assistance where a student is still allowed to complete the task, but through their own efforts, they will not succeed by guiding and prompting their efforts. And this mediation process of learning happens everywhere, whether we like it or not. It happens in everyday occurrences. But when it becomes intentional, it can become the engine that drives the learning process. So, thank you for bearing with me on the theory. Now on how I try to open the zone of proximal development in 2 of the undergraduate courses that I am teaching in chemical engineering. One to the second year students in the first semester. What semester are we in now? No, it's this semester, your second semester. And one to the final year students in the first semester. So the aim is firstly you must create these activities. You must create a task that opens the zone of proximal development. And you must provide the scaffolding, as many of you referred to today. And preferably create differentiated scaffolding. In other words, realizing that not all students require the same amount of help. Some may require more and some require less. And then to provide timeous feedback, but not the kind of feedback of you are right or you are wrong, or this is why you get 60% when you give summative feedback, but feedback that they can still use while they're busy doing the activity to improve. Right, so just some background on, to give context on how I presented these courses, so where did this activity of the online test fit in. For all the courses, both courses, I presented all the material asynchronously through pre-recorded videos, lecture notes, textbook readings, and that's supported, of course, by a very strict schedule. And they got Monday reminders of the schedule to say, this week, remember, watch this video, read that, in the hope that they actually, so every Monday, through ClickUp announcements, this is a reminder of the schedule. And then we had two types of synchronous activities, one 3-hour tutorial session per week. At the start of this COVID, I didn't really understand the word synchronous and asynchronous in this context, but I am now fully aware of synchronous and asynchronous teaching activities. So the synchronous activities, we had one 3-hour tutorial session a week. And so we used, the group, students were divided into 9 groups. It's about, we don't have such big classes, fortunately. So it's about 10 students in a group, and they were forced to participate in collaborative problem-solving sessions, text-based. And these sessions were facilitated by the TAs. And for the text-based sessions, we used Slack. You can ask me about that if you're interested. But also in 2021, I started having a collaborative BBC session open where I could have, similar to what Talia was explaining, a plenary session where you just set the tone. And if you just see that sometimes text-based, it just runs into its limits in terms of providing help for the students, we could call the students to BBC and say, okay, let's quickly just have a group discussion, and those sessions were then recorded. The benefit of the text-based tutorials is that it's available for the students who also want to asynchronously attend those sessions. But their participation was graded using a rubric. The TAs graded that. And then we had one Q&A session per week where they could send their questions before that session, and that was also done in BBC. So these last two activities certainly does meet the brief for a social constructivist learning environment. However, I felt that even though I forced participation in the tutorial sessions, and the students did participate, I had great participation, for many of the students, it still excluded them from an authentic learning experience. Many students are shy to show their vulnerability, that they don't know, so they don't want to type stuff there where forever it rests that they couldn't do it. So even though it was not about being right or being wrong, or they were not at the same level of preparedness of the members in their group, they had load shedding, they had data issues. So I felt many students were excluded. So these online tests is what I used in Blackboard, so in ClickUp, as an asynchronous attempt to open the zone of proximal development. So I used the online, the test canvas in ClickUp, in Blackboard. There was one test for each of the study themes. It was available at the start of each of the study themes. It was, what the test involved is a complex problem on the study theme or a set of problems that you have to solve, right? The test opened at the start of the study theme. It was called a test, but it's more an assignment rather than a test. And they had unlimited time to then engage with this test. But it had a due date because at the end of the study theme, the test then closed, and at that point you had to submit your attempt. They also had multiple attempts, but not unlimited. So just to bring some, you really have to pay attention, between 2 to 3 attempts. And in between the attempts, I wanted them to get immediate feedback that they could use to improve the next attempt. So not just, okay, you were wrong, but you were wrong maybe because this and that went wrong. So how was this employed? So in the, this is just a few screenshots. Alistair, forgive me, I'm not a ClickUp teacher. But in the test, the description, he helped me a lot. In the test description part, so where you start your test canvas, is where I then made the big problem available. This is your online test. I uploaded in many instances just a PDF because all the symbols I needed is not available in ClickUp. And then the first level of scaffolding is, so this is typically an online test. So this is the big problem. This is the problem. And this is what you, in the end, have to answer. So it's lots of information. You have to understand the content. And this is what you need to, at the end, this is what you need to achieve. And the first level of scaffolding was provided by how the different questions were then guiding them through the problem solution process. So it's not typically what you will get in an exam. In an exam, expect the big problem. You have to solve this, or in an assignment. But these tests were scaffolded, so you got the scaffolded questions, and each of them was then employed as a separate question in the test. So this was the first level of scaffolding. And then the differentiated scaffolding, I discovered this useful immediate response on feedback on correct and incorrect answers in the test. So in your individual questions, you can then tell the students, okay, well, if they're correct, so this is when you are building in the test options, when you are building your test, when you get it correct, you can say hallelujah or well done or give them a joke. But if they did it incorrectly, and this you can only do when you're older and you've got more experienced, so you taught the module a few times, you know what students are typically struggling with. So you give them some hints. Maybe you did this incorrectly, have you checked your units? Or go and watch that example again. Go and watch my video. At minute 2, you will find an example of how you should calculate that. And this, you now can set up the options. You can set up the options in your test canvas to immediately, so you give them, must just remember to give them the immediate, the multiple attempts, the highest grade was used. And then how do you want the results to display is give them the feedback immediately after submission. And don't give the answers, just the feedback and on the incorrect question. So they can see what they got incorrect and they can get the scaffolded. So, you know, some hints. You got it wrong, maybe this is what you got right. So it's me kind of predicting what students will get incorrect. Did it count? Yes, it counted 15% of their semester mark, but there were 7 to 8 of these tests, so it's very low stakes. Unless you don't do any of them, then it's 15% of your semester mark. And then there was another opportunity for interaction. They were actively invited to ask questions about the test. So it's not like a typical test, so do it on your own. You can ask as long as you don't ask what's the answers. Also in the Slack-based, in open channel. So this is just an example. One student asked a question. Another student jumped in and gave some advice before I could. And then I just jumped in with a few replies just to make sure that, okay, I agree with student B. And finally, we closed the feedback loop. So this is the online test in ClickUp. And then for each of the tests, they had to submit their files of how they got to the solution. Written work and Jupyter Notebook, their Jupyter Notebook files, most of the problems required them to solve it using Python in Jupyter Notebooks. And if they still couldn't get it, the TH then went through that and gave them some participation, method marks. Yeah, grade them and gave them feedback on what they then are still missing in this whole thing. So this is how it's employed. The only reason I decided to share this with you today, and thank you for staying awake, is because of the overwhelmingly positive feedback I got on this. So I must first qualify that I was so desperate for feedback that it doesn't take much for me to see something as being overwhelmingly positive. So this is, but what I must state is this wasn't specifically invited on these online tests. It was just a normal student teaching and learning feedback form that they get the link, and there's a question that asks which activities that you find most helpful, elaborate on them. And if I counted the amount of positive comments I got there in that part of the feedback. So in the final year class, 83% of the students, that's quite high for me, actually participated, actually gave feedback. Only 30% of the class, so it's just less than, actually took the time to write something. But 70% who wrote something had something positive to say about these online tests and how it contributed to their understanding in the module. The second years, even less responsive, but 60%, but 50% of them wrote something in the comments. And once again, lots of positive feedback on the online tests. And just some, I just show some of the quotes, but some of the main themes that emerged on why they found the tests beneficial is because they're low stakes, they are prepared to take a risk and try it. They're prepared to try to test their understandings. Because they get a multiple attempt, they also try to get it. They found the hints in the middle, in between, helpful. It helped them to stick to the schedule. It improved their understanding. Lots of it improved. It helped to improve my understanding. It helped to improve my understanding. So I realize that there are many flaws. You can point out many weaknesses in this approach. But based on the level of interaction I received personally from the students due to these online tests, if I should keep one activity when we go back to full face-to-face teaching mode, this will be it. So thank you. That's it. Oh yeah, some references if you're interested. Going, tea time. Okay, thank you. I won't. Okay.
Thank you.
Thank you.
And I hand over back to Prof. Alter.
Thank you. I want to thank everybody that stayed, and even on, I know that some of the people that left said that they're going to go online now because they asked me the links. I want to thank you for staying. I want to invite you for a last cup of coffee just outside, and the way we can then just network a little bit more. I want to tell you that we are planning to come back next year. This is the current plan. There are 3 ways that we can do this, and we call it case 1, case 2, or case 3. Case 1 is where you take your class and you divide them into 3 or 4 groups, and you still stream this year's videos to them in the other periods, but that there's then at least one student get one opportunity to get to class per week, or even 2 a week. The other one is to do something streaming, just using those cheap cameras that we, well, I won't say that it was cheap. It was, but the cheaper type of cameras. The good news is that we are going to get very expensive video equipment in 80 of our venue rooms over a period of 2 years. So next year, they're going to do 40 of the rooms, and the year after that, another 40. Which will be very expensive equipment which we can then stream with. The challenge will of course be, as you see today, for us to stream this event, we had to have people that can help us with it. Hopefully we will be able to get better ways to do that in our classrooms. So I want to thank you once again. Have a great afternoon and great evening. Now you can go and do your emails. Thank you. Thank you.